Hey everyone, David Hilster. How are you tonight or this morning or wherever you are in the world? I am David Hilster, your dissident science person. And today, see, I've got my hat, physics, please. I've actually had this for a while. But tonight I'm doing something I promised a lot of my people who are my subscribers. They'd like to see some live sessions where I can interact with anybody. And in fact, if you want to and you want to join and talk with me live on YouTube, you can. All you have to do is go to this link here, greenroom.dissidentscience.com. That'll take you to the waiting room here. We have room for as many as 10 people. But again, I'm David D. Hilster, and today I'm going to be looking at some headlines in physics, some really interesting headlines, of course, always in the news. I don't always get to look at them and talk about them in my videos because those videos are planned, scripted, and take some time to put together. And when I do that kind of video, obviously a lot more people will watch for a longer time. It gives people a more sense of something with the story, with the beginning, middle, end, that kind of thing, and the graphics. And I found that those kinds of videos I can get my message across a lot better. But of course, they take quite a lot of time to do. So the idea of these live sessions are for you guys to be able to answer questions. Also, for me to take a look at things that are in the news. But regardless, I want to thank everybody who's showing up today. I also I thought I was putting this also at the same time to the CNPS's YouTube channel, which actually got just over 700 subscribers today. And I do want to thank all my subscribers, the new subscribers. I know these videos don't get as many views, but my goal is not to get lots and lots of views necessarily with these live sessions. It's more to give people a chance to ask questions and me to interact with my subscribers directly. And so I want to again welcome everybody. And as my physics police hat says, I feel that way sometimes when I see these headlines. So let's go ahead and start there. Again, if you want to come and talk with me, you take your browser, even on your phone, I think it works. You can go to greenroom.dissidentscience.com. It'll take you to this waiting room, which you then will appear, and I can bring you up and we can actually chat live on the air. So if you're interested in doing that, you are absolutely welcome to do that. So let's take a look at a headline here. Um, Let me put my face there since we have that the space. Get that banner off of here. Um, Here, what I normally do is I look into. Let's see. Here we go. You can see this. So it's a good place to look for science articles to talk about, headlines that sort of grab my attention, and those definitely come from one place you can get them is in Google. If you go to Google and you look up news.google.com, they have topics. You click on science, and you can actually click on physics, and you get all kinds of wonderful, marvelous things from mainstream science, which I like to talk about a lot with my friends sometimes. But now I'm going to be talking with you guys. And the first one, of course, caught my eye. It says astrophysicists observe long theorized quantum phenomenon. And I'm always very suspicious of that. And of course, I think I was right because I have taken a look at this. I don't know if we can make this bigger. Let's see. We'll just make it bigger and make it easier to read for you guys, or sometimes those things don't behave well when you make them bigger. Okay. But anyways, it's got this planetary nebula NGC 2440 central star. Is possibly the hottest known white dwarf star discovery. But again, it's a long theorized quantum phenomenon. So if you want to know my opinion about quantum mechanics, it's quite a big joke in my opinion. People are well intentioned, but quantum mechanics is extremely lost. It's as far from physicality as you can imagine. And it sounds amazing. It sounds complicated. And that, of course, is the game of all of science and physics is to be the smart ones, explaining to all of us the difficult notions of the complicated universe, when in reality it's not the universe that's complicated, it's our notions that are. So I'm going to read a little bit of this and give you my thoughts here, especially when we get down to some of the particles here. Does this have the W and Z particle? I think it does. I believe it is. If not, it's in one of the other articles. But here we go. At the heart of every white dwarf star, the dense stellar object that remains after a star has burned away its fuel reserve of gases, and it nears the end of its life cycle, lies a quantum conundrum. As white dwarfs add mass, they shrink in size until they become so small and tightly compacted they can no longer sustain themselves, collapsing into a neutron star. This puzzling relationship between a dwarf's mass and size, called the mass-radius relation, was first theorized by Nobel Prize-winning astrophysicist, and I won't pronounce the name, in the 1930s. Now, a team of Johns Hopkins astrophysicists have developed a method to observe phenomenon. I think this is a different one. I was reading one about the W and Z particles, so I may be totally wrong on this. Let's keep going and see what this says. The mass-radius relation in a spectacular combination of quantum mechanics and gravity, but it says the mass-radius relation is a spectacular combination of quantum mechanics and gravity. And that's one of the big things they're always looking at. Now let's just step back and think about what this is. Quantum mechanics has to do with supposedly the mechanics that are inside atomic subatomic structures, and it also has been the biggest quest in physics today, is to put this together with gravity. And of course, that's what they sometimes call the relativity part of it. And so you get this quantum mechanics and gravity. That's the big thing. Of course, if you look at modern models that we are coming up with, my father and I have a model, other people are coming up with models. There's no worries about these things because you have to have a model for what gravity is. You have to have a model for all these things. And the problem is we don't have it. So what they're trying to do is put gravity together in quantum mechanics when they don't know what gravity is. It's just a bunch of mathematics. So the theory has existed for a long time, but what's notable is that the data set we use is of unprecedented size and of unprecedented accuracy. So their measurements, they've looked over the years. So this is not, I'm so embarrassed. This is not the article I wanted to look at. So yeah. Oh, yeah. So this is a newer one that came up while I was put this up on my screen. So here it is. Sorry about that, folks. This is the article that I was trying to look at. Those people who are watching in the recording, I apologize. Again, if you're wanting to join me, you can go to greenroom.dissidentscience.com and you can join in, and I can put you on the air and we can talk. You can ask questions, discuss something that's interesting to you. But here we go. This is the one I really wanted to look at. Start all over. Long-standing tension in the standard model addressed. I always enjoyed the standard model. And of course, in the standard model we have, I guess, some type of lattice. Oh, that could be a lattice of somebody's lattice work for a different model of the universe, but that's not what it is. It's a graphic to attract people's attention. The best known particle in the lepton family is the electron. Of course, the electron is a lepton because it's non-divisible. That is, the electron is a primary or elementary. Well, that's not true. A lepton is not that. Electron is an elementary particle. I'm sorry about that, because I don't subscribe to any of that anyways, so I don't worry about the lingo for it, because I don't believe that's to be true, that no particle has no parts, and that's what they say. They say, in fact, the electron is elementary and there are no subparts to an electron. Something I don't subscribe to and many people don't. But it says the best known particle in the lepton family is the electron, a key building block of matter and central to our understanding of electricity. Oh boy, do I have to laugh about this. What's really funny about this is that electricity is, if you ask somebody in standard about in the standard model what electricity is, Electricity and current, you have electrons moving in one direction and the current moving in the other. And the current moving in the other are the holes left behind by electrons. So the idea that we know what really electricity is, we say they're moving electrons. Well, the problem with moving electrons, according to the standard model, they move at meters per second. And we know very well that none of the, how do you say, none of the electronics that we have today would work, because we know electricity is flying around often at, it's sub light speed, but it's close to the speed of light. It's going extremely fast. So when you're looking at the key building blocks and our understanding of electricity, is nil. Again, people are coming up with models of it. Lori Gardia and Yonel Danu just came out with a video describing what they think electricity is. My father and I think we have a model of what we propose electricity to be. But the electron is not the only child, it says. It has two heavier siblings, the muon and the tau lepton, and together they are known as the three lepton flavors. According to the standard model of particle physics, which is a problem, the only difference between the siblings should be their mass, 200 times muons 200 times, tau lepton 17 times, and the remarkable feature of the standard model that each flavor is equally likely to interact with the boson. Now, that is, I guess what makes this difficult for me is that they're talking about the particles in the standard model. And let's look at this. My mentor was Dr. Karazani, and one of the things he said is we got to throw out most of particle physics from early 1900s. Who else says that? Dr. Alexander Unsker, a physicist alive and well and kicking, who has his own YouTube channel. Look him up, Alexander Unsker. And he does excellent videos and does excellent work and wrote some amazing books. A book that I recommend every person who likes physics to read is the book Lost in Mathematics, is by Sabine Hossenfelder, another German physicist. But no, his is The Higgs Fake. And so when you hear the standard model that the flavor is equally likely to interact, I mean, it really blows my mind that in the standard model we have anything called flavor. Because what we're doing, as Alexander Unsker points out, is we're taking arbitrary attributes and giving them packages of stuff and giving them arbitrary attributes to arbitrary packages. And that's what we're really doing. And when we talk about the flavor, it's likely to interact. Oh, I am so sorry. That's just kind of absurd. Oh, I saw you in there, Shockwave. What's going on? I saw you in there. I was talking, but happy to bring you on board if you do want to talk. Anyways, when you look at an article like this, and I have my police here, I can see here my physics police hat. Basically, I have that hat on by looking at this with critical eyes, critical thinking. And of course, the standard model is sort of funny because I don't know how standardized it is. It's hard to really find. They say it's standardized, but it's there's a lot of versions of it. And also it's a model, and it's not a model at all. It's a theory with particles, and those particles have no physicality whatsoever, because if you go and look up, for instance, quarks. Look up quarks in Wikipedia and get the picture of quarks. They are circles drawn, and they label them. They give them colors and attributes. And it's so funny because the idea for quarks was, everything's made out of quarks. Doesn't turn out that, didn't really work out that way. And all the quarks have attributes, and we have no physicality. We have no, is it round? Is it this big? How does it make up a proton or a neutron or whatever they make up? There is just absolutely no physicality. So when we look at the standard model, it isn't a model at all. It's proposed particles. We're never told what those are. We're told that there are pieces sometimes, and they're made up of these things, and they come up with all these arbitrary types of attributes, as I say over and over, repeating both Karazani, who said Z and particles and W particles, you can throw those out. And of course, if you go on, it says in a new study described in a paper posted today on Arvix or Archives. Oh boy, I always see that, and I never thought about that. It's archives, and first presented in the LHCP 2020 conference, the Atlas collaboration presents a precise measurement of lepton flavor universality. Do people buy this junk? Do they actually get together and believe all of this stuff? Do they just talk about it so much? I mean, I really think that inside these people know they're talking baloney, and they just talk about it because they've dedicated so much time to it. Oh my gosh. I mean, a lepton flavor universality using a brand new technique. This is crazy. Harry Potter is way more believable than any of this. Atlas physicists examine collision events where pairs of top quarks decay into pairs of W bosons and subsequently into leptons. The LHC, the Large Hadron Collider, is a top quark factory and produce 100 million top quark pairs during the run too, says so-and-so. This gave us a large unbiased sample of W bosons decaying into muons and tau leptons, which is essential for high precision measurement. So they're smashing things together. They see these paths that are going on. They assume all these paths are certain things. They have filters for them. If you read the book The Higgs Fake by Alexander Hunziker, you'll find out that their engineering methods and filtering is very suspect. So pretty sad. And anyways, it is something that is it says this gives us a large unbiased samples of W bosons decaying to muons and tau leptons, which is central high precision measurement. Okay, we read that. Then they then measured the relative probability that leptons resulting from boson decay to a known ratio as R over tau over mu, according to the standard model, should be unity. 1, I guess. The strength of the interaction should be the same for lepton muon. But there has been tension about this ever since the 1990s when the experiment showed blah, 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 and the deviation was not, in fact, that. The new Atlas measurements give this number to be very close to 1, of course. This is the most precise measurement, and of course, this verifies their model. Okay, let's see. I've got some people here talking. It says, if so, why do weak forces have such time? Okay, I'm going to go back to some of the discussion here. Put this back up here. Let's see. Well, lots of discussions. What's on the agenda? It says it's post Discord. It'll post this link to. I'll post this link to the Electric News Discord. Okay. Can you post that link there? Chat, of course. I'm reading all these. The neutron star and what's the life of the neutron again? 15 minutes. Okay. This is somebody Shockwave, who's the one person who's doing lots of comments here. There's a couple other people now showing up and making some comments. Gravity is their king when we know electric force is 100 trillion times. Well, I am going to say this to you, Shockwave. I mean, I am a big proponent of anybody who is out there trying to come up with new models, and I am a big proponent and supporter of all of them, even if I don't agree with them. Now, I will tell you that working on our own model for the universe, my father and I, something we never planned on doing, but kind of fell upon and are working on our model has that. And what it says is that the universe have all those characteristics because we see those things and they are different and they're caused by particle movements that are very easy to understand. That's according to our model. So when people talk, the only thing I would say when people who support the electric universe is that a couple of things. One, you have to understand if you don't have a physical model for what an electric field is, what its charge, because in our model, we have no charge. We have gravitational field of particles. We have magnetic field of particles. We have electric flows of particles, which is we don't call a field. And then we also have luminic particles, which are basically waves of particles which create light. Now, we have a model, so we can look at part of the universe and said, this is gravitic, or this one's luminic. And those are some of the words I came up with myself for our model. So to say that the universe is electric, you have to have a physical model of a physical thing, tell people what that is, and therefore then say, this is why it is electrical. Now, does this make me say, oh, all electric universe is wrong? Of course I don't. Not at all. The electric universe does great work. But I think when we make broad statements that, oh, we all know, for instance, I mean, you make this statement that gravity is their king, and we know electric force is 1,000 trillion times stronger than gravity. Well, it definitely can be stronger. And in our model, it is stronger. An electric flow is stronger than a gravitational push. If you're talking about the level where you live in here, which is we have in our model, you have levels all the way up and all the way down. But regardless, we can tell you in our model what is electric and what is gravitic. Now, to say one's more important than the other, no. The way you can't say any of this unless you subscribe to some type of model. And I'm not here to tell you and say to everybody here, our model is the best. No, our model is our model. Whether people accept it or not when our book comes out and people see it, that's another story. The people who know the model, a lot of people do like it. They do like the way it easily describes the way things are in the universe. And we can say, yep, that's magnetic. Yep, that's electric. Yep, that's luminic. Yep, that's gravitic. And so what I would say is we need to be careful, even in the dissonant world, even in the electric universe, to declare winners in the universe as to something unless you can, the only way you can do that is if you say, oh, here's my model. It's written out here, right here. Here's my model of the universe. This is what light is. This is what gravity is. This is what magnetism. This is what electricity is. Therefore, when I look over here, this is electric. When I look over here, it's gravitic. When I look down there, this is magnetic. And I look over here, it's luminic. So again, I welcome, and it's great. If you are an electric universe person, great. But I'm the physics police, and I'm not going to sit here and let people, even myself and my father, our book is a model we think is less wrong than the standard model. Now, is it right and provable? Nothing is right or provable. What you can do is have models, and those models should be able to show you how the universe works, makes predictions perhaps, and allow you to do things in the future by looking at predictions and say, oh, maybe I can manipulate the universe because if this model is correct, I should be able to do things I can't. So when we say that the electrical force is so much stronger, we have to be careful to say, is that more important? And do you have a model? So Shockwave, do you have a model you can show me what an electric force is and what gravity is, and then show me why the universe is more electric than gravitic? In our model, we see not equal, but we see things of all of those four types everywhere. And again, we have a way to measure that and say, okay, when it's going in a circle, it's magnetic. Okay, if it's flowing all together in a direction, that's electric. If it's flowing all together in a direction in waves, that's luminic. If they're in random, all over the place, like the air here that we have, the air molecules, that's gravitic. So again, we have a model. Is it right? No, no model is right. It can be less wrong than the other models, but we must be careful about going out there. One of the things I see people in electric universe is it's all electric. Gravity is a joke. Throw it out. Be careful. I always say, okay, what's your model for gravity, by the way? And one of the things I do know is Wal Thornhill, who I personally know, and Dave Wal Thornhill, is that, yeah, Wal Thornhill, and Dave Talbot. You know, I applaud those guys because they're out there fighting mainstream, and they're even doing that experiment, the Sapphire experiment, which is fantastic. But we have, if you were to ask them, they are trying to, for instance, try to describe gravity as an electric part of the electric field, I think. It's at a subatomic level, if I remember correctly, their model. So, again, is that correct? It could very well be. Absolutely. Um, I think a lot of times, though, when people have an overall arcing bias toward the universe, meaning everything's electric or everything's gravitic, yeah, it's gravity on one side. But, well, they all exist. We know those things exist, and I actually agree with a lot of the premises of electric universe. That a lot of things in the electric universe that they point out, which we think are, there's no electrical force involved. It is, and these things can go very long distances. I'm in agreement because I got a model, and I can tell you how that can happen. So I know that they're working on gravity, but they still have charge. They still have a magical charge, which means if I put a plus on my hat here and I put a negative on my microphone here, they're going to attract. What is that? So that's the other question. I'm sure people in the electric universe and even Walt Thornhill have been thinking about that. So just be careful. If you're electric universe, what I would say, here's the way I say. If I'm a member of the electric universe and I consider myself a member, a fellow brother in arms with the electric universe people, because I'm all for people looking at new models, because we don't know what the next new model, which will be a model most people will accept, will be. I think that's great. I would say, oh, yes, I subscribe to Electric Universe. I think there's a lot of things in the universe that are really going on, that the electrical part is being overlooked. And it could be even major parts of what's going on. But I would not go as far and then say, no, the universe is all electric. Unless you have a model of everything. Once Walt Thornhill gives me a book, hands me a book, and says, here, Dave, read it, because I've now got a model for all these things: physical, magnetic field, gravity, the electric force, light. Here it is. And here's what it is. Then I said, okay, I'll read it and say, hey, that is really cool. And then you could then, using your model, make a claim that the electrical part of the universe is this, and it's a majority of it. That's great. I'm not here to say that's wrong. I just say when people make these assumptions, because the electric universe group is quite large now, and people subscribe to it, that's great. But you've got to know the limitations of what you are looking at. Just like my father and I know the limitations of our model. So again, this is just my opinion. Like I said, Electric Universe, keep doing what you're doing. In fact, the Sapphire Project is really interesting. If you have not seen it, go on the internet, go to thunderbolts.info, and you can read about the Sapphire Project. Let me put that up there. I think it's put this up there, thunderbolts.info. If you've never been there, take a look at it. I think that's how it is. And go there and look at the Sapphire Project. Well, the Sapphire Project, the way I look at it, is they're trying to recreate what's going on in the sun, because the Electric Universe has a very different model for the sun. I know there's another gentleman, he's from Ohio State, where I went, go Bucks, and he has done he has his own YouTube channel, which is doing well, way better than mine. Well, the reason mine is because I don't pull my punches from anybody. So it takes a lot of, all my subscribers have good thick skin here, but he is, I'll find him, and he has a model of the sun, and he does a lot of great videos. Star Scholar, I think it is. Somebody here may be able to say, but he's a Sky Scholar. So the Sky Scholar is there. The Sky Scholar also has a different model of the universe. So absolutely, these people are doing really amazing experiments. The Sapphire is an amazing experiment. And what I see is that somebody is actually trying to show something that's going on with a model, well, not a model, but at least the notion that the universe is more electric, coming up with models, for instance, for the sun that's very different. I applaud them. I am not one at all. It's not my specialty. If I will never tell you that the electric universe's models of the sun, which may be different, are in fact wrong. No way. I think what's more interesting, though, from the Sapphire project is the really heavy, I can't speak, the really heavy elements they have on that they are created, that seem to be creating from these electrical discharges. And I think that is real interesting because if we can make heavy elements and we could do this in a way, who knows what could be going on and how we could use that and what that actually means. So to me, that's really something that I would like to look into more. But I think they're using it more, I guess part of the premise, I think again, the premise is to show that the sun works in a different way and there are things going on in ways that the electric universe people think, and they give models. For instance, they think the Grand Canyon, I think, is scarring from a large electrical event. There are a lot of different explanations for that, but hey, that is a model. And so they are looking for this to support a lot of their ideas. But I think what they found could be more interesting than that support of that idea. So who knows? But I applaud them a lot for that. Somebody's asking about Dave. You ever heard of black light power? And if so, what's your thoughts? I don't know about that. I can maybe look that up, but I am not real certain about that. Let me go back. I know there's just been so many comments here. I'm going to try to rip through these and see electric force reaction. I'm not sure what this means. Electric force reaction is 1 over r squared. Well, if you look at the Coulomb's law, it looks very much like a gravitational law. And it turns out in our particular model, my father and I's particle model, is that anytime you have anything that bends, like a gravitational field, we think those are random particles in random directions causing that. Well, we also know that electrons bend around the orbits of atoms. Well, we have particles at this level. Well, you can have particles that are way smaller that are doing the same kind of randomness. So you have particles, let's say they're this size, and then you have particles way smaller that actually make those particles move. So there's like another teeny weeny small, really small particles going way faster than the speed of light, going and making random, and that's what the gravitational field. So we think that's a gravitic field. And because when we think of a gravitic field, it turns out then that the equation for Coulomb's law is just another variation of the gravitational law. Do we say everything's gravitic? No, there are 4 things in the universe. So it's interesting that you put that there because in our model, all the Coulomb's law is the attraction is just a bunch of smaller gravitons, you would call them, G2 particles at another level below that causes that. So that's just an interesting thing. Okay, I have shockwave here, and let me put up some, get the banners down here. So again, we're talking about keep up the great work. Everybody who's in Electric Universe, I am not out there dissing you in any way. I am 100% in support of what you do. I am the first person to say that what you guys are saying could all be true because, proof is proof. It's not proof. All we can do is have support for our models and ideas, and that's what we have. So what we are, when we're out there and we're talking, we should support everybody's work who is doing work, who are trying to come up with new models because the standard model sucks. And yes, people don't look at the lecture. So thumbs up, you guys keep doing good work. Now I've got Shockwave here. I don't know really who he is. Hopefully he's a good guy. From the comments, he seems good. If it works out, great. I'm taking people on faith here and want to talk. I'll talk to anybody as long as they're polite and aren't here to sell something, but I'm here to discuss whatever. So if you, Shockwave, have hopefully, if you do come on, you need to have ear plugs or how do you say, ear, I'm sorry, folks, one of the reasons people go, why, Dave, do you forget how to say words? Well, I speak Portuguese every day, 50% of the time. Eu estou falando português e outras vezes, outra metade, estou falando inglês. There you go. There's some of my Portuguese. When I get a thought in my head, sometimes I think and I think in the other language and I try to get, hey, it's a mess. So my poor brain. So I'm trying to make an excuse for my retardedness, but anyways, you need to have headphones or earbuds or something like that. It makes it a lot easier with the microphone. We're not going to get feedback. But anyways, I'm going to bring you on if you're okay here. And I know we have lots of comments still. So here we go. Let me add you to the stream. All right, Shockwave, you are there. How are you?
Can you hear me?
I can, and you don't sound like you're gonna sidewind me because we do have trolls. Believe I know it's hard to believe
No,
that your
no, I'm just
gender would be troll. I'm kidding, but
no, I'm just heavily into the electric universe.
oh well, that's really good. So, how long have you been with Electric Universe?
I found it about 5.5, 6 years ago now, and
Oh,
was
okay,
I was always into the ET thing and
right.
history and geography or geology and
Oh, okay.
science. I mean, atomic bombs and
Oh, yeah,
World
yeah,
War
sure.
Two and World War One, and just history, right? And
Right.
looking for the truths. And
Yeah, yeah.
what I've found in the electric universe is I think they've hit the nail on the head with history, with comparative mythology for sure.
Oh, okay. So you subscribe to the comparative mythology with the you got that one man, which is,
Definitely.
and also what's
Saturn
his name,
being our ancient
Velikovsky.
sun. Yeah,
Yeah,
Velikovsky.
yeah. Well, it's interesting you talk about Saturn being our ancient sun. There's actually it's not competing, but a different view of how the universe sort of,
Hmm.
is evolving and growing. And I'm one of the people that the evidence for the Earth expansion is just quite dramatic.
I
For
believe it
me,
too. Yeah.
it's if you look at the data and you see it, you just can't go back. So if you look
Gravity.
at that
Big,
now,
the biggest dinosaurs couldn't even move without snapping their bones, ripping their tendons. You, no, it
yeah,
had
it
to
doesn't
be
happen.
less.
Did you get to see my
I will.
interview
I was
with?
there. You didn't see my commenting.
Oh no, I probably did, and I apologize. I'm a linguist and I forget people's names. I'm a visual
Shockwave.
person.
That's me.
Shockwave. Well, thank you, Shockwave. And it sounds like because I got my master's in
I'm a
linguistics.
recent subscriber, so
Oh well, thank you so much. And also, you sound like you're from the northern part of the hemisphere. Is that true?
Canada, eh?
Hey, I love Canada. Canada's beautiful. In fact, we have
Toronto,
our.
Canada, in fact.
Oh, nice. I drove up there once. I won't, yeah, at the time I was before I was married and I was dating a Chinese person and there was a big Chinatown there. Is there still a big
Oh
Chinatown
yeah,
there?
it's huge. It's
Yep.
it's it's one of the biggest Chinatowns in North America,
Well, it is.
besides BC,
Right,
Vancouver,
right, right,
and
right,
San Francisco.
right. And it's funny because we did have our conference, our CNPS conference at the University of Vancouver, British Columbia. And it
Oh
was
yeah,
so beautiful there. It's ridiculous there. It's such a nice city. It is really, really beautiful. I'm not familiar as much with Toronto, but I know, of
I've
course,
been there
Vancouver.
myself when I
Oh,
was 12 years old. My mom flew us, myself and my two sisters. She flew us out there to visit our grandparents, and she drove out. But we spent the whole summer there. It was amazing. All the monkey trees, the
oh,
nice
it's so
warm
beautiful.
weather, beautiful.
Yeah, it is very beautiful. And so, oh, you
So
must
you wanted to
turn your
talk
volume.
about the model for the electric universe.
Oh yeah, I turned my volume down because I was doing I worked during the day like everybody else at their normal jobs, and I had. Is that better? Is that better the sound for me?
It was fine before.
Oh, it was fine before. Okay, I got to make sure because I have a tendency when I get excited to yell, and this microphone is what I use for my recordings, which can be very good. But I said, go ahead, say that again one more time.
Well, you said you wanted to talk about a model that the electric universe has for the universe, basically.
Yeah,
How 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 the physical universe works.
well, no, no, no. Okay, okay. Let's step back, and that's a good. It's good that we discuss, and this is one of the reasons I like to. I think these live sessions are valuable. Let's stand back. My dad has a meme. In fact, let's see if I can show that meme. I just literally put it on our book's website, and he says something very profound, in my opinion. And everybody, really needs to understand what that means, because very, very important. Okay, I'm going to show us this. There we go. And this meme is right here, folks. Let's see if I can get it bigger. And the meme says, when it comes to either light, gravity, magnetism, or electricity, science today tells us what it does, which you were saying, not what it is. So
Exactly.
that's that. Yeah, but I want to say to you is what you were about to say. Say the English words you said to me before. You said you wanted to know about a model, but you were going to say, I'm going to tell you how it works.
I'm going to
If
tell you
you
how the electric universe model works,
right, whoop,
how
whoop,
they
whoop,
think
whoop.
it works.
Okay, now hold on. All right, let's just step back and look at the language. Okay, and I'm not here to, I'm not. First of all, I'm not to argue what you're going to say is not even true. It may be true. It may be parts of the electrical universe that I myself accept. But when you say this is how the model works, that's what my father is telling you. We have a model for gravity, but we don't know what that is. The model for gravity is space-time, or the model for gravity in electric universe is the electric field. What I'm
Dipole.
saying to you, right, but what I'm saying to you, you can have dipoles, you can have monopoles, you can have all kinds of poles. I'm a person that's going to say to you, that's nice, but what is the electric field and why is there attraction? That's what I'm saying. So when you talk about, if for instance, space time, this is the way it works. A body comes by this and this has happened. So you will describe to me Birkeland currents. You're going to describe to me how these things are working. It doesn't tell me still the major part of the electric universe that I want to know, and that is not how gravity is part of the electric field. What is the electric field? What is it? Is it ether? Or
Opposition
what
of
kind?
charge.
But charge is a attribute we have that came from actually from Ben Franklin. What charge is, what you're saying, what we are saying with charge, there's an attraction, and because I put a plus on this and a minus on this, these are going to attract. So this has a charge. What is charge then? If you're going to say, okay, well, what is charge, and why would charge make things come together? Now, what I'm going to say to you is
Well, you have to have
there's
also charge potential, which
what's the potential? Where's the field?
anode and cathode relationships.
But what are the forces? What is the actual moving thing that causes this
The
thing to
movement of
move?
those particles that are charged,
But why do
either
charged
positively
particles
or
move?
negatively.
Now, yes, but what I'm saying is, here's what I'm saying to you. I'll call you Shockwave, okay?
Yeah,
Shockwave
that's fine.
is
You can
that
call me Rick if
is
you
okay,
want.
Rick. That's much better, Rick. But here's what I'm saying. We have a model, for example, and in our model, we don't have charge because we say, as a rule of the universe, charge is an arbitrary thing that we've put together to make attraction, to describe what we see in the universe as attracting. It does not say how that actually happens, because when what you're saying is there are dipoles or this, and you have a positive over here and a negative over here, and those things attract. I'm saying to you, in our model, we'll tell you exactly why. There are little particles that are pushing it over there, and that it's not charge that's negative and positive. My father is
But
an
the elect
electrical engineer.
but the electric universe says that those charged particles, when they rather if they be positive and negative, when they come close to one another, they do not contact one another.
Okay, but let me ask you this.
They orbit.
What
They start
force in the
orbiting
universe,
each other.
what force in the universe causes whatever this magical charge is? What force causes those things to come together? I'm not talking about how it works or whether they touch. I'm saying that you have something which you call a charge. You put it on something, and to me, that's sort of a convention. And that convention comes from Ben Franklin. He was the first one to call positive and negative on some things, and it was a convention. When you talk about that and say,
We'll
well,
talk
no,
about an
that
electron and a proton.
exactly, in the way we
One's
have it is
positively charged, one's negatively charged.
that is a theory and a
And
model.
that's
But it does
plasma.
not tell you, it does not tell you, it does
That's
not
what the
tell me.
universe is made up of in the eyes of the electric universe. That it's made up of plasma, and this plasma gets organized into filaments, and
I
then these
understand all that.
filaments, these Z pinch down onto
You're
Berkeley.
talking about the result of electric currents and positive and negative charges.
Right.
I'm
Well,
asking
if
you
I
to
could
say
explain,
what those are, not
but
the
but if
traction.
I
I'm
could
trying.
explain, if I could explain what gravity was or what magnetism was, I'd be a Nobel Prize winner.
Well, we have a model that describes light, gravity, charge, not charge, magnetic fields, and electric flow.
Right.
All of those. And it's a physical model. That is, we can tell you the reason the electron stays in orbit is because there's very much a whole another level of very teeny weeny, very faster than light particles going in random directions that causes a shadowing effect, which makes the electron orbit the nucleus. We do not need a charge on the electron. We don't need a charge on the
But that's when we
nucleus.
go into the ether. Do we
No,
know what?
I don't believe either.
Do
No, our
we? Do,
model is not. Wait. Hold on. Hold
hang
on.
on. Okay.
I don't have. Our model is not an ether model. We have no ether.
No, I understand. No, but I'm saying that's where the electric universe goes into the ether, saying,
Oh,
well,
they are subscribing to ether now.
I'm theorizing this part myself. In
Oh,
the
okay.
1930s, there were two physicists that theorized that an electron are two photons.
Yes, I've heard that.
We have the equipment now to test this theory, to verify whether or not two photons become an electron. So
Mm-hmm.
then we're starting to talk about the waves and the energies that make up the universe in the non-material universe. In other words, the ether.
Okay, but okay. So you're saying, first of all, I do know that you're talking about what you would
That's my
call a different
view.
model. Now, what you're saying is now you're getting a little closer, and that would be, and there are some people who have these kinds of models. If you've never looked at Jeff Yee, he takes an ether model, has standing waves that create um, the particles themselves as standing waves.
Right, right. And we look at quantum waves and we see what?
but you said,
We
yeah,
don't see particles, we see patterns of wave patterns down in the quantum realm.
well,
Correct?
no, I don't agree with that. I don't agree with that because the evidence they give is, in my opinion, built on a house of cards. If you go back
Well,
and
they're
really look at
expressed
it,
in wave patterns
yeah, they're expressed in wave patterns because they have mathematical
because
wave
they're,
things, and they think that that the way, well, they don't know what a field. They use mathematics.
yeah,
Standard model uses mathematics. So the moment when when they say a wave, for instance, they say light is a particle. They say light is a wave. They have no idea. When you ask them what that is, it's a
exactly.
photon.
That's the thing.
Well, a photon, but but I know a photonics expert who spent 40 years of his life studying photons, and he says if I take five 1/5 photon emitted energy emitters, that is, I emit the energy of 1/5 of a photon, point all 1/5 of the photon beams at a one photon detector, which they do have, and that detector goes off, he says, we're out. We don't have no, he has studied the photon for 40 years, and he says to our faces that he has no idea what a photon is. And so
Energy.
energy
I
is a
think it's energy
concept. It's a concept. Energy is a concept. That is
but there are
absolutely true.
in my view, there are many different energies. Like, for
But
example,
energies are concepts. How give me an example of a physical thing you can put in my hand that's energy.
well, X-rays are energy, radio waves are energy. There's
Okay,
all
then
kinds
what are
of
those
different
made out? What are
energies.
those are made out of?
Light is
That's
an energy.
photons. So photon is an energy. Photon is mass. There's a mass if you believe in the photon. It has mass. And well,
Well,
they say it doesn't. But here's the thing. When
it does and it doesn't. That's the
well, that's the
strange
problem.
thing about a
Here's
photon.
the way I say in physics. The reason I'm the physics police is you cannot have a world where you have things that give force that don't have mass. I think I am a person you'll never convince differently from that. I this idea that you can have things without mass, that you can have space time that's what they whether it's a rubber sheet, it's a foam, it's a quantum foam. We I think what happens is people in science, people who look at these things, we use vocabulary constantly and not think of what the actual physicality is. If you take the average person on the street They're going to say, just tell me what gravity is. What is it? Is this the particle? What is it doing? It's something. It's a force. So something's hitting me down. What is that? Oh, this is light. It comes and it burns me. What is it? Oh, it's a particle. It's a wave, but it doesn't have mass.
Well, we know mass
Do you
and
think that
gravity are
makes
tied
sense?
together.
Do you think that makes sense? Do you think that you can have a force that burns through things, that I can shoot at something and burn a hole through it and say that doesn't have mass? That makes no sense to me. And
Right.
I think what I'm saying to you, Rick, is we use vocabulary so much. We end up talking in a vocabulary world, and we talk about charge, and we talk about dipoles, and we talk about electric fields. And then when a person asks us, well, what are those? Then we punt to ether, and then we say, oh, well, what makes the ether? How do you get lasers out of ether? Because ether would be like sound waves. I can't
You need a
make sound.
T-shirt that says "Words are hard."
Words are hard. I know, because
Words are hard.
my whole living and for the last 30 years has been to try to get computers to understand words of humans, and boy, do we humans use words in funny ways, for sure. So, oh,
Well,
here's
exactly.
here.
We call the solar wind a solar
Yeah.
wind when we should call it a voltage potential.
Well, what is the voltage potential? In reality, my father's an electrical engineer, and he'll say the voltage is a standard that they came up of measuring what a current, and they have no idea. My dad's a very successful electrical engineer in research, and he
Right.
will tell you, the first to tell you that in electrical engineering, in fact, probably a fourth of our book is using our model to tell you exactly what electricity is, how it works, how do transistors work, how do batteries work, using real physical things. It's all Newtonian. Everything's Newtonian. But he's the first to tell you that voltage is what those things are wonderful systems, but they have nothing to do with reality. And my father, he and I, and I'm not here to tell you that our stuff is right. I'm just telling you from a perspective, somebody who has a model, that when you have a physical model and you can explain it, that is the thing that we're missing. That's why when we see this meme of his and that says, what we have science telling us what it does all over the place. We have equations to tell us how Birkeland currents work. We have theories about how Birkeland currents work. We don't know what it is. Well, it's plasma. What is plasma? Well, plasma is what is that? We keep
Plasma is
getting.
charged particles, basically,
Okay,
opposing
but
each
I am
other and,
telling you,
and
charge
moving
is an
along.
arbitrary thing we've invented that was invented by um, Benjamin Franklin, and that it is a convention. It is not a reality. Because you tell me, charge is a wonderful convention that people use. But if I'm a person who believes there's no force in the universe, including magnetics, including what we would call the electric force, then I will continue to pound my hand on the desk and say, tell me what that
Well,
is
see,
physically.
a lot of people, I think, elect the electric force and magnetism are separate entities.
Well, again, give me. I can give you a picture of
You
what we
cannot,
say
you
they
can
are,
have,
but what are you saying is? I want to know
you
from
cannot have
you.
a magnetic field without movement of charged particles. In other words, movement of electrons
So
or
you
protons.
subscribe to that theory, but that's not a model. That's an idea that people have. There is no We have no physicality to describe, a chart, what charge really is. We have no physicality when we say a charged particle moves. In fact, one of the things that a number of us
But we
who
see
now,
these twisting pairs of Birkeland currents everywhere in the universe. I mean,
sure,
I just looked at a
but that
twisting
that
pair of
sure.
filaments that come off of Sagittarius A.
Yeah, I know, and we can describe that without charge
We
or
see them in the radio telescopes. That
I don't
big
think you're
curve
listening. There
of
are
Birkeland.
models, not only our models, but there are other models out there who can describe these things physically without charge. Now, in
Well,
Occam's razor, but with
yeah,
Occam's razor, you
yeah, I'm
can
fully
tell me
aware.
all day long that it's charge. But if someone comes along and says, I can do this in Newtonian, just clashing, bashing particles together, and I can tell you why and how they move and why they move that way, and they don't need charge, and all they need is Newtonian physics, then the question becomes, what are we talking about? A system that's more complicated. that in it's really hard. It takes a while, Rick. It takes a while. I have fought many years. In fact, Yonel Deneau and Laurie Gardee. Laurie Gardee is actually from Canada. She works with fractals. She's called the Fractal Woman. Look her up. Watch.
She hangs out with us
Right.
on the Electric
She
View.
just
We
she
do
just
a
came
show
out with a
every
video
Sunday.
showing that, and she state a paper with Yonel Deneau. Go read it. She just put it out there publicly that says charge is not a real thing. Lori Gardee says that. So,
I haven't watched
yeah,
much
well,
of her videos recently, so I have to
well,
go
that's
back.
okay. That's okay. I'm not here to,
But
put you
Lori's good. I
down.
like her.
Yeah, but I argued. I remember arguing that idea with her for a while. We met. In fact, I got her to go to our conference in Vancouver, and I love her work. In fact, I'm using a fractal in our book because we believe that infinite up and infinite down in the universe. We don't believe there's a particle that doesn't have parts.
Scalable, as above, so below as above.
Yeah, well, turtles all the way up, turtles all the way down. But
Or
when
DNA all the way up,
I
all the
don't
way down.
believe she has subscribed to the idea, even if she would say, because I remember arguing with so many people that year. It was 2017 we were there, and my father and I were talking. There's no such charge as an arbitrary thing we've put together, and people say, no, it's a fundamental thing of the universe. And I said, think about it. So what I'm saying to people is okay, let's say you believe there's charge. Well, if I put a model, even the model that Yonel Deneau and Laurie Gardee are now taking, an ether model, trying to do the same kinds of thing my father and I are doing with a particle model. These two models, there's Jeff Yee with another model. So you have Laurie Gardee and Yonel Deneau with a model, no charge. I'm not sure. I don't know if Jeff Yee has charge. I can't remember. Our model has no charge. And there are other people who also say there's no charge. Those are the models of people who I think are really coming up with good models these days in the dissident community. And if you have a model that's simpler and doesn't need charge, and I'm presenting this to the public, what do you think they're going to say? You're going to say, that's funny. You got to put this. When you tell an average person on the street that if, oh, I put a plus on this and I put a minus on this, they attract. You know what the person's going on the street goes, what does that mean? Does that mean wherever I put a plus? Oh, no, this is charge. Well, what's charge? And probably it's a fundamental thing of the universe. The average person is going to walk away and say, I am absolutely not satisfied with that answer. That's my feeling. And I think that's one of the reasons for almost 400 years since Newton, we really haven't gotten, except for Einstein saying gravity and light interact, and people kind of understood that. I did my last video on that. I think people want to know what it is. And I think that's what a lot of people in the distant world, my father and I are doing this because we're tired of getting the equations of how this goes or how the Brooklyn currents do that. I want to know what the Brooklyn currents are in our model. They're G1 particles, and we can tell you why they're staying in the configuration they do. We can give you reasons for that, and we can give them in Newtonian terms. Is it right? No. No model is right. Our model is hopefully less wrong. We put it out there, it could be all wrong. No one will accept it. No one will buy it. And my dad and I will have a nice book to put on my shelf back here. No one cares. But the
I'll
thing
have
is,
to look into your model a little bit more. Are there any videos on the channel here that
oh, my dad does. That's all
explain
he
it a
does
lot
is,
better?
yeah, my dad's called the particle guru. And again, I'm not here to put, that's not my goal on this channel. My goal on this channel is to be here talking with you. First of all, I congratulate you. The most important thing is you're here talking about it. You can't talk to Neil deGrasse Tyson about any of this. He'll laugh. And these are
Oh,
the
no
people
doubt.
who are the science evangelists out there on the mainstream media who push the mainstream idea. So if you say I'm in the electric universe, they go, oh yeah. Or you say I believe in the ancient rock petroglyphs and these interpretations. I wasn't there 30,000 years ago. I
I
wasn't there to
refuse to
know.
bow to the white coats.
Right. And what I am a person that personally I don't really subscribe to that, but I will tell you I didn't study it enough to really have an educated opinion about it. Number two, I wasn't around 30,000 years to know if Venus flew in or not. So the whole thing is we have to get to an attitude where Oh, you believe that? Go knock yourself out. Make a huge group, get as many people believing or wanting to believe this stuff, put experiments out there, write papers on it. Go for it. Knock yourself out. And if it's right, the group will grow and that's will become the paradigm.
Well,
Again, the only
the group that I hang out with on Sundays on YouTube is called the Electric View, and
right,
Neil Thompson was a presenter at I think the 2016, maybe 2017
right,
EU conference.
right.
So he runs the Electric View show, but I'm just there because I love this stuff, man. I mean, like I'm reticent of telling you this, but I'm only grade 10 grad. I've only graduated
Oh
grade
yeah,
10,
but that doesn't mean
and
squat.
it's I've always, like I said, I've always been interested in history, geography, science, the
Hmm.
sciences of all kinds. And the ET question brings me to where did we come from? Why are we like what we are? And I think with Velikovsky, I think he nailed it. I mean, completely nailed it
No, and
with
I think,
why
like I
we're like
said,
what we are.
yeah, and what I think is this. I I think that we all the number one problem in science is that we have the science police, right? And they basically teach you truth. They don't teach you to critically think. I
Well, they
mean,
teach
if
you dogma.
right. And so when Neil deGrasse Tyson was asked if Einstein could be wrong, his first response was laughing. Now that is the worst kind of answer to come from a scientific or philosophical mind. Here's the rule in science: anything almost can be right, almost anything, and you
Oh, I'm pretty
cannot.
sure Einstein quoted is quoted as saying, "My theories won't last."
Yeah, well, the problem with Einstein was is it well, it's a long story, but it has to do with the atomic bomb and people
I know,
accidentally put them together, and after he
I know the
died, he
story.
no, but Israel was making Israeli university until 2010 was making over $10 million a year on his name, on his image because he willed it to him. And then the time when I was making my film, I was worried about that coming out, so I was trying to use the fair use laws by using his likeness and all that. And it turns out that they challenged. I don't think it was GM who used his head on the body of some buff guy for a car commercial, and so the university took him to court because they say we have the rights to his image, and it turned out that the statute of limitations ran out. Well, all this is money and fame. Neil deGrasse Tyson, the last thing he wants to do is teach people to be critical thinkers. If he was a real, true person, he'd be who really looked for truth in science. He would say, "Of course he's wrong. Everything's wrong. What we are, like my
He
father
would
says,
keep
it's
his
just
mind open, but not
yes.
so open that his brain
The
falls out.
electric universe is wrong. My dad's and I's theory is wrong. What we say, it's less wrong, perhaps, than what's there now. And we don't teach children to do that. In fact, a friend
Well,
of mine, Andre,
the-
a friend of mine from Brazil, he's an engineering teacher in one of the really great universities on the other side of the Rio Bay, the Bay of Rio de Janeiro. He was teaching his class in engineering, not physics, but engineering. But he is a dissident thinker. So when he gave engineering students says, okay, you're going to pick the Big Bang. You can pick a big subject in physics to write about. You are required by me, the professor, to give us the support for the Big Bang and support against the Big Bang. And he did that for many years. And then I called him up to say, I want to get some of the ways and techniques you're doing this because we could multiply this idea around the globe. So I called him up a couple of years ago and we started talking, and he goes, Dave, I can't do this anymore. I can't go public. And I said, why? He says, a third of my students enjoyed that exercise immensely. Another third didn't care. They just did their job and did their assignment and went on,
right.
right? Another third ended up going to my boss and my dean and telling them that I was spreading blasphemy. And all
Yeah.
he was doing was requiring his students to be critical thinkers that no matter what it is, Let's say you believe in equal, you want to show that equal voting rights for women, for instance. So you give your assignment to a kid and say, I want you to take both sides of that. Now, I don't care if you agree or disagree with whatever side, but you're
That's
going to be
bordering
learning.
bordering
That's
on
in
religion, David.
what?
That's
Yeah. What?
bordering on religion.
What's
The way
bordering on
those
religion?
that last third, the way they reacted, that's
Of
bordering
course.
on religion.
It's not bordering on the religion, is religious. That religious is when you do not have critical thought. When my dad and I are doing, if you go to our website, and there's the if you people are interested, my dad and I are our own worst critics. We think that the model is worth something, that it has a lot to say, and perhaps give the world. But we're the first. We know more about the weaknesses than anybody, even the people who follow our model very closely. But that's the true meaning. In fact, the first part of our book tells you and again, this is not telling about, this is the way we think in general. The first part of the book lays all the foundations for our model. This is the premises that we have about the universe. And from those premises is a toolkit where you can build the entire universe physically. Now, my father's an interpretation, and using these rules, I literally say it this, everything in this section is wrong. This is a book on our theory, our model. And the reason I say that, because it's true. This is our best guess of how to use these new ideas that we call that's why we extended Newton's laws and theories to have these other new ideas that most of them we didn't come up with. Two of them we did, my father and I did. The rest we stole from other people because they're good ideas. That's the way science works. We stand on the shoulders. But we say in our own book that this is wrong. We do not go around saying, and let's say that people like it and people use this. And they use it to do things like we have already done, to explain things we can't explain and look at new ideas. Okay, they do it. But if you come to me and say, yes, oh, well, ours has been proven right because of this, that's baloney. You can't prove anything. And I think the problem is our attitude. I am here to encourage you to go as far as you can in the direction you can. I will put you to task when you use words and you use terms. And maybe I've been around longer and I had it hit into me that be careful, energy is a concept. Think about it. Yes, it's a concept. It's a very useful concept. But why does energy have 1,000 different units? If energy was something, that's a word, then it would have the same unit. It doesn't have the same unit because it's a useful concept. That's not a real thing. It's useful. But I'm here, we talk about those things. We talk about the names. We talk about the electric universe. I'm just saying, what I'm saying is we need to just be careful about when we use our language that we don't become married to the language, to even the electric universe. If you're in the electric universe, you need to be skeptic of that itself. And I tell people in the
Oh, I
electric
have
universe,
questions about some of the theories of the electric universe.
well,
That's
the thing I have, the question
question
for the
about
electric universe is one question, and I've had it since I've known about the electric universe, which was 10 years. I gave an award. I helped give an award to Wal Thornhill. I know him. I respect him greatly. I respect all the people. I respect the Sapphire people, all those things. But I still have the same question for them. What's an electric field? What's charge? I'm not going to stop saying that until I get an answer. And it's not that I'm right or wrong, or that the electric universe is wrong until we give that answer. No, the electric universe has really wonderful predictions about the way the things work. Not what it
oh,
is, but the
wait,
way they work,
we can
right?
talk about the predictions. Yeah, well,
Exactly. But it's
comets,
not a model.
Velikovsky, and
Right.
Venus, and predicting radio signals from Jupiter and Saturn, and I mean,
Right. Yeah.
I mean, if your model is mostly correct or correct, you can predict things like that,
Yep,
and
you can. Or you can
that's really
explain
what
things too.
exactly like a neutron star, for instance. They say the the standard model says that a neutron star is a star made up of neutrons that spins 30 to 60,000 revolutions a second.
Hmm.
That's the speed of a dentist drill and higher.
Hmm.
And it won't fly apart. No, there's
Hmm.
something else happening there. And you can, your dad as an electrical engineer, he can tell you the process. I don't know the process's name, but there's an electrical process that will do that. Will send out a pulse every 30,000 or 60 thousandths of a second.
Hmm.
It's things like that that
Yeah, yeah, I
make me
know. And
stand up and take notice.
right. This is something I hear a lot. Something I hear a lot. Quantum dipole moments is supposed to explain gravity. That's from Electric Universe, right? My question is, we keep passing it down to another system, right? Oh, the system before was this. Now it's this
No,
system.
actually, it's not quantum dipole. Wallace, I've only heard Wallace talking about atomic dipoles.
Okay, let's say atomic bomb. Okay, we'll say dipoles. But I'm still going to say the same thing. We're still talking about our electric fields and dipoles have charges, and I still haven't had my question answered. Because and the reason I asked that question is because other models answer that question. Now, if the other model answers that question and tells you what electric field is, you can, from a model that tells you what electric field, explain everything else that the electric universe does. Now, I'm not saying that the electric universe is, first of all, it isn't a model. It's a way to look at the universe, saying that it's more electrical than we think. That's the way I look at it.
Well, all there's really saying is if you add the electric force into the gravity slash mass model that we have today, things will make a whole lot more sense. As for instance, the spin of our galaxy and the ability of our galaxy to keep together and not fly apart with that rotation that we have.
Well, wait a minute.
That
Let's go.
is
I know. But let me
that's
step
a
back on
dark
that one.
mode. That's electric
No,
in
no, no.
dark
Hold on,
mode
hold on. Dark
in a
matter is
deep
not
edge.
needed. No. Newton
Oh,
explains
I
that.
know. Yeah, dark matter.
Dark
Dark. Yeah,
is
it's a
no,
fake.
no, no. Hold on. The reason they say I've done a video on it. If you can look up Dissident Science and
95%
dark.
of the missing matter in the universe is supposedly called dark matter, and it's supposed to
It's not
hold the
missing. There's no
or the
missing mass.
galaxy. Sorry,
But there's no
together.
missing mass.
I know it's an electrical force that holds
No, no,
everything.
no. It's not electric force either. There's no missing mass. There's no electric force to take its place needed either. See, people don't look at where it came from. Where does the idea of dark matter come from? It comes from looking at a galaxy, and a galaxy is in spinning in space. They then calculate the mass of the galaxy, and here's where it goes wrong and why they've shown their cards. Again, my video describes all of this. We already know there is no dark matter. It was invented because they don't understand that the gravitational field, even a Newtonian gravitational field, is not a sphere. So when you look at the gravitational field of the galaxy, it is not a sphere. We live in galaxies that are planar, and they have arms. So when you look at a potato
Spiral
asteroid,
arms, in fact.
right? So the whole thing is we know for a fact that the real gravitational field that exists in the universe around a galaxy is not spherical. When you go the same distance to the edge of the galaxy and measure gravitational field, you have a bunch of stars that line up to that. And so that direction toward that middle of that galaxy has a lot more gravitational pull because they're on a line, no matter what gravity is. I'm not saying what gravity is. Now you put it up here, you don't have that. So what happens is now they found two galaxies without dark matter, they say. And the reason is they're spherical. That means all these stars on the edge of all a spherical galaxy, if you calculate all the mass and put it at a point, you have a spherical gravitational field. So yeah, you don't have no anomalies. That is, the stars are going at the right speed. If you take Newtonian forces, like his name is Cameron Ribisol, he wrote a paper on it. I refer to that in my video. He took the galaxy and broke it up into pieces, into arms, and made those things and because we know again that a rectangular force is not a gravitational field that's spherical. An arm is not spherical. And when you do those calculations using Newton, guess what? The speeds of the stars on the edge of the galaxy are described by Newtonian gravitational mechanics, which means there is no dark matter. It's not that they can't find it and it's electrical. It doesn't exist because they can't recognize the simplest fact that gravitational fields around galaxies are not spherical. And if people believe they are, I said, send a probe that goes around all these stars and all of these concentrations. Will the probe going toward the center of the galaxy go in a straight line? Absolutely not. Well, then how can it be a spherical gravitational field? It's not. We know that. So what I'm saying to you, Rick, is it's not that the electric universe can explain dark matter. Dark matter was invented because we don't even know how to admit that gravitational fields around non-spherical bodies are non-spherical. And we know that. NASA will tell you very closely, very abruptly, that that's true, that the gravitational field around an asteroid that looks like a potato, it isn't spherical. They know that. So why are we treating the galaxy as a spherical mass, putting it at a point, calculating the gravitational pull on the edge of the stars, knowing that that is not a spherical calculation, but we don't care, throw up our hands. And then when we find spherical galaxies, oh, we say it's not there because why? It is really a spherical gravitational field. So the explanation is right there in front of us. When I saw those, that just came out in the last couple of years, that there are two galaxies that they say have no gravitational field, and I was the one doing this without. I didn't even know they existed, and then sure enough, they go, "Oh, these don't have dark matter." No, what it means is that you do a spherical calculation on a spherical galaxy, you're going to get the right speeds of the stars, no matter what it is. Oh, it means no. It means that you're calculating it incorrectly for the galaxies. Again, I encourage you looking that up. But that's what I'm saying. What happens is until you look at all the things, we a lot of times in dissident science, it's another problem we have. We'll say, oh, I know what the neutrino is. Well, guess what? If you look at the origin of the neutrino, it was used to save Pauli used it to save special relativity's mass increase, which is not seen in particle accelerators. So I know dissidents who use the particle neutrino for their ether, and I'm laughing and I go, guys, the neutrino was invented to save. It doesn't exist either. So we have to be very careful. One of the things, Rick, one of the reasons people in the electric universe or people like we don't do it in our model because that's not the way the world works, but other models and people have their models. They want to use the vocabulary of the mainstream science because they have this hope that the people will accept electric universe or accept the Jeff Yee's model or accept Ginsburg's model or accept Laurie Gardy and Demu's model. They'll accept all these models that are out there competing, or James Carter's model. They're hoping that using those terms, they'll go, oh, yes, dark matter's there. The electric universe found what it is. It's this. Oh, the electric universe, right? We're all going to be an electric universe. That's the hope of people who try to please mainstream science. Science doesn't work ever in any paradigm shift to please the mainstream. It doesn't work that way. But we're emotional beings. We want to have people accept our idea that the electric universe model or again, I don't call it a model because to me it's not a model, but there are a lot more electrical things than we really know about and explain, which I can agree with wholeheartedly. But we want the mainstream to adopt it. So we'll tell them what this is. We'll tell them what that is. And we hope using their terminology, or we can explain dark matter, which, believe me, someone's going to pretend they found it. They're going to give them their pretend prize. Everybody, but that's why I'm out as the physics police, not only to mainstream people, but to us dissidents. We can't fall into those traps. We can't fall into the trap of loving this idea or this direction so much that we get blinded that, all we're doing is substituting another model that still doesn't tell me what charge or electric fields are. That's what I'm saying. So the electric universe, I like the ideas of their explanation of what's happening. I don't see the model of what it is, even with gravity, because if gravity depends on electric field, you still haven't told me what electric field is. Oh my goodness. So that's my take on it. So the other question I have for you is, You were in Electric Universe. Have you been to any of? Did you go to any of their conferences at all, or not?
Oh no, no. I'm I
No.
work from paycheck to paycheck. I don't
Oh yeah, yeah. I
you know,
understand.
so I can't afford to go to Phoenix every year or anything like that. So
Yeah, I think they
I
haven't
just watch the
done for a while.
Thunderbolts
Yeah.
videos, and
Right.
they make a whole hell of a lot of sense.
Right, right.
And
Yeah, and I think again, what I think is important, what I'm only telling you, Rick, is be careful when you're talking about it because you don't want to be too married to anything. We're not married to even our model. You have to be a skeptic all the time. You have to understand that here's the way if I were you and if I was an electric universe, I said, boy, it explains a lot of things that we think are explained in different ways, but I think the electric universe explanations are better. Yes, we don't know what electric field is. We don't know what charge is, and it's based on that. But the explanations for the things in the universe,
did you mention ARP?
Halton Arp. Oh yeah,
Yeah.
yeah, no, Halton Arp
Well,
is
I
he's
think gravity and um, the growth of a quasar are tied to electron density. The more electrons you have in the system, the 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 more gravitic the system is.
ooh, he's using my word. All right, that's cool. Um,
Oh,
gravitic.
gravitic?
Yeah.
I got that from Star Trek, bro.
Oh, they had gravitic in Star Trek? Really?
Anti-gravitic?
Okay, yeah. I've never seen the term used actually.
I
Because
thought it was from Star
because
Trek.
no,
Maybe
no.
maybe it's from Tesla and T. Townsend Brown's work.
No, I don't think it is. I honestly did. I came up with I at least independently came up with that word because I needed a word to. Let me show you. Just here.
Well, that's what I described Tesla's work as.
Right, but I'm saying that these electric I knew of the word, magnetic I knew, luminic I never saw, and gravitic I never saw, and this is our model in a nutshell. But I looked that word up, and I'm a linguist. I never saw that word before, even luminic. So I sort of came up with them to come up to be an ick word for gravity and light. So that was something
Interesting.
I came up. So now
A
that's
scattering field kind of thing.
well, that's gravitic. This is our model in a nutshell. Basically, the universe, anything that creates curved or orbits is called by a gravitic field, whether it's this level or it's a level below us or a level above us. If it's moving galaxies that are going in random directions that cause a gravitic field for even bigger objects in the universe, magnetic is just simply a loop of particles. Electric is simply particles going in a direction. They don't have to be in a straight path. And luminic is what my dad came up with in 2015, which really kicked off our model, which is light is simply waves of particles, not one particle. So that's,
Right.
but I'm just saying that gravitic and luminic were words I came up with because I had to come up with them. Now, I've never seen them anywhere. Doesn't mean that that's right. I don't claim, but I was curious because I
Interesting.
used that word today, and I thought you picked up on. I go, oh, you picked up on that thing. So,
No, I've
but
been using I mean
gravity.
anti-gravity, and then for years I've been saying, talking about Tesla and T. Townsend Brown's work that they figured anti-gravitics out.
Well,
That's
I don't
how
know.
I
Well,
use
here again. I'm going to come back at you. What did they say gravity is? I can't believe there's anti-gravity until they tell me what gravity is. I mean, you can't. If I tell you, oh, this is English, and this over, and then there's
it. You're gonna
anti-English, and
laugh, but
they don't tell me
it
what
has to do
English is.
with charge.
No, but what I'm saying is
Opposition of charge.
the only problem I have again, and I think it's great. Tesla did a lot of great things, but his idea of transmitting, for instance, power, people says we can do that. I said, well, what's your model for what he's doing? What is gravity? What is light? What is electromagnetic waves? What are all those things? Once you tell me what those are, then you can explain to me. Then you can tell me and show me how those things are going to be transmitted. Now, if you look at what he was doing and take, for instance, our model, which is one that I don't know all the models how they would do it. Well, it turns out that we would say the way he was trying to transmit what he called the power, it has a very limited, a limited amount of
Well,
travel. So,
I think I
but
figured
again, we
out
have a model. We have a
lit his
model
light
for it. So
bulbs.
according to our model, that's what we say. Our model could be totally wrong, right?
Well, I think I figured out how Tesla lit his light bulbs. He increased the frequency of the electricity to the point where it would not penetrate into the body, and it would just flow over the skin, and it would flow over any surface and make a connection.
Hmm.
I think, the air that he was standing in when he was doing this was alive with electrons. It was just like
Yeah, but
moving
again,
electrons
I
like
understand
crazy,
what you're saying. I understand what you're saying,
and
but I'll get
the
back to it. And
electrons would just flow over top of the bulb, making the contact regardless, without a socket or anything
but
like that.
electrons have charge, and charge moves in a certain way. And again, I mean, it's a system that you're describing, but I'm still trying to figure out, those other. So we have an observer saying electric, magnetic, gravitic, and luminic is idiotic. Oh, well, here's, and these are the kinds of things, and this is something that you're going to encounter where this is not even a logical or philosophical debate that goes on that you have. So if I were to say to you, Rick, that charge was idiotic, did I ever tell you that charge was idiotic? No, I'm just asking you, tell me what it is. I don't believe it's a real physical thing. I never accuse you of being idiotic or you'd be stupid. And unfortunately, when you deal with people and you give them, you put some idea out there, like our model with gravitic, magnetic, electric, and luminic, even two new words, they're going to go, it's idiotic. What kind of this is why it doesn't matter, because people who are like what we call trolls, people who I've taken me a while to be able to understand, it, when you have like Neil deGrasse Tyson laughing at the possibility Einstein could be wrong, when we have the head of our organization, the John Chappell Natural Philosophy Society, the head chief scientist is a woman who got her PhD in special relativity from MIT, and whose first job was to apply it to a ring gyroscope where light goes in a circle. And guess what fell apart before her eyes? Special relativity. Everything she wrote her dissertation about failed miserably in the real world. Now,
Well,
why,
that's
why,
the same
why,
reason.
why
Sorry,
doesn't Neil deGrasse Tyson look at her and her work? If you were to tell him that, his answer would be laughing, or that's idiotic. Well,
I
that's
would say
idiotic.
spending billions and billions of dollars on tokamak type reactors is idiotic.
Well, building
And
particle colliders.
they have not got one reactor to run more than a minute without trying to destroy itself, because they're using the wrong damn model of the sun. They think the sun is atomic. It's electric in its very nature.
Yeah. And they
And
put,
I mean, if your model is correct, it's going to show you amazing things like what Sapphire is doing. Sapphire is seeing 9 elements of the 11 elements that we detect in these Magellanic clouds out there. And
right.
we're seeing the same elements in the chamber. Not only that, they're creating heavy elements like
Oh, I
titanium
know.
that was not
It's
present in
amazing.
the chamber to begin with.
Right.
They
And I mean
also
that.
have they have 5 elements that they have not, have not disclosed what they are.
Sure, sure.
For
Yeah.
what they're doing is they're monetizing this, and they're trying to make money from this so that they can build a reactor to make power. You know about the 7% dark mode energy heating event that took place?
Well, here's what I would say. I think it's absolutely awesome what they're doing. I think it's absolutely awesome the things that they're trying to show. I
But we're
think that
alchemists. That's what
I
I'm
th-
pointing out. We can make elements at will
ex-
in these chambers.
right, but but we still need to know how that actually happens. But they're showing that can be done.
Well,
I mean,
they're using different catalyst gases to
sure,
make different elements in the chamber come up. They're using spectral analysis
sure. Yeah,
during
no,
the
I saw it.
running
Yeah.
of the experiments to see
It's
what's going
absolutely
on a large
fantastic.
scale, but they're also using small scale electron analysis of the probes and the things that and the anode and the cathodes. They're having those analyzed as well to see what elements that are being created on them. And I would suspect that one of these five elements that were created in the chamber would be gold or platinum or silver.
Yeah,
And if that's the case, that is so big that it's amazing. Not only the fact that they can create power over unity power from an effect like this chamber runs at 80 watts. You're aware of that, right?
yeah, yeah, I
The
understand, and
experiment
I understand what
had
the
a
over
maximum of 80
unity.
watts.
Uh,
And when
yeah,
they were at 7%, that's what, 6.5 watts, they experienced a runaway heating event, which will allow them to put a cooling chamber around the chamber and make steam and create power. They're going
but
to
let
be
me just say, let me say this. One of the things that we have to be careful about when we talk about over unity is because, in my opinion, that's not the correct way to look at the universe. If there's movement that's coming, because in the end we're getting
over
movement.
unity just means to me, it means making more power than you put into it.
But there's no, you can't, the universe doesn't work that way. What happens is, in my opinion, if they were to find something, is that something's happening which we don't have an explanation for. And once we find what's going on, the conservation of mass is what we call, because energy is a concept, it still exists. You don't
Well,
get something from nothing.
they're looking for $20 million to build the first prototype of this machine.
Right. But what's happening, I'll give an example. It could be they're tapping into the gravitational field, whatever, whatever model people subscribe to that. And it looks like it's over unity, but it's coming from somewhere. It's coming from somewhere in the universe. There's
It's
no
just
such thing as,
it's just a runaway heating effect. They don't know. Uh, they don't know exactly what's
I
causing it,
understand. I
and they're
understand. And I
looking at
support
trying
their
to
work on that.
understand
Yeah.
what's going on right now, currently.
Yeah.
And
I understand that. And I
but
think
they
they
know that
should put money
the
on it.
effect is there, and that they'll be able to build a generator that
That's
will,
great.
in fact, power the unit itself and provide electric power on top of that. To me,
Right.
that says over unity.
No, the what it says to me is there's things going on in the Sapphire project, which I have totally support, and I applaud them and will support them against any criticism. But I will say there's not over unity. What would happen is that what we would find out is our model of what's going on is incorrect. That movement from the universe, whether or not we're unleashing things from levels below, from things below, we have no idea what they are. It's there. It's just that we don't know what it is. So yes,
They may figure out that it comes from the quantum fields or
yeah.
particle.
Again, all I can
They
say
might
is
find
that
out
that's
later
blah
on
blah.
down the road. But I
Quantum
mean,
fields, foam fields, are to me is blah 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 because
it's
it's
like
again, it's just mathematics or a concept. There's no, I can say it comes from the tooth fairy who comes along and gives it to the sapphire once a day on Tuesdays and this a quantity, but it doesn't mean that's what's
no,
really
but it's
happening.
repeatable though. That's the thing, David.
No,
This is
no, no, no,
repeatable.
no. I guess people, no,
Repeatable,
no, you're
right?
not understanding what I'm saying. I'm saying about the over unity. I'm not saying that what they're doing, what they do is happening, but the idea that it's getting something from nothing or over unity is a wrong concept. What I'm saying to them is the Sapphire project is creating heavy elements. I will take my hat off, and I'm the first to say that's revolutionary. That is amazing. But then,
That's what
and then
humanity
if
is
it
trying to
does,
do for the past
if they can use this to
thousands and
generate
thousands of
power, great. But to say it's over unity, I will fight against that constantly. What I would say to people is, we don't know what's going on. There is conservation of movement and mass there. We just don't know why this is going on. Eventually, we will. But to say it's over unity to me is not true. What it says is to me is that
to me it says to me in my mind it's over unity, but into your mind it's not over unity. So that's
no
okay.
over unity.
Like
No,
like
no,
like that
no, 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 no,
Philip
no.
Ford. Well,
You
hang on.
know,
Like
it's
an
not okay.
Albacore's comment, he's allowed to have his comment. He's allowed to have his thoughts. We're
No, no,
all
no,
allowed.
wait a minute. I'm not arguing about comments and thoughts. I'm talking about conservation. Over unity, I claim, isn't allowed, even the phrase, because it's talking about breaking conservation, and that is wrong. It's not something that the way you see it or believe. Conservation of mass and energy, all that stuff in the universe is is in my opinion is non-arguable in my opinion. So it's not a case that, oh, it's like I said, I can believe in fairies, and yes you can, but I'm saying that over unity is not something that you have a different opinion. I'm saying it's against every one of the most basic things in the universe. You cannot create things from nothing. It doesn't happen. And over unity is not a colloquial way we use. The whole idea is that we get like this free energy from somewhere. As long as you say, what we should say is it will create a very efficient and new way to get energy. We don't know where it's coming from. It could be coming from this or that, but it's creating energy. It could be a
All,
really
all,
great thing, but
all
it's
I
not.
know is on the Sapphire presentations, Monty was describing the efficiencies
Yes, I
of
know.
the
I,
different
I, I saw it.
electrical powers.
I watched that. I watched the presentation. And when
The,
he says
the
that it's,
Sapphire the Sapphire project is going to be far, far above wind power, which is
oh
the highest
no, that is
efficiency at the moment, which is 1,000%.
absolutely great. I think that's great. But what I do will fight against tooth and nail is this
Okay, I won't
term
use
over
over
unity.
unity anymore. Stop
No,
beating
no,
me up already. Stop,
no, no,
stop.
no. I want. I guess the whole thing is not
I'm
even the
joking with
beating
you.
you up. It's, do you understand?
I'm
Here's what
joking with
happens
you.
when someone describes to me, like you describe what over unity is. I then understand. I do understand what you're. I try to understand your side. What it sounds like is I give an argument against, and you say, I don't try to understand what Dave is saying about over unity. I just let him say it and give up. I'd
Okay,
rather
well,
you.
I'll explain that
No, my
concept a
explain my
little bit better.
argument. Explain that. No, explain my argument first, so that you would understand what I'm saying. Because if you don't, then we're not having a dialogue. What we're doing is I understand what you're saying. What you're saying is this: when you look at Monty, what he's
Well, I
describing,
understand that you
and
said
I know
that
what
you mentioned
over unity is. You
conservation.
claim to be putting in, let's say, 10 joules of energy into the system, and you're getting 12 out. Now I understand that, and I understand over unity. But when I say, my argument is there is no such thing as unity. If you put in 10 joules and 12 come out, 12 are coming out from somewhere else that it exists, from a mass that we don't know of.
Something. Yeah, I agree. I agree. We don't
So
know.
over unity, but
As
over
I said,
unity comes
don't.
from, if I understand where over unity, the concept of over unity comes from, it comes from the idea that you're going to get more than you put in,
Exactly.
but that there's no such thing.
But what if I mean, if the concept is there and they're planning to build this device
They're getting
that
it from
will
somewhere
hang
they
on,
don't
hang
understand.
exactly.
But that's not over unity. That's not over unity. You can't
But
have over unity and then say that that's that. It's not.
if this device is running at 6.5 watts
Yes,
and it's heating some water up,
right.
and this
Uh,
water is able to produce more than 6.5 watts
It's getting
that we
energy,
can
it's getting
draw
movements and stuff or mass and movement from somewhere else. It's
from
not over
somewhere,
unity.
from some phenomena that we don't understand at the moment, and that
Yep,
that Sapphire doesn't understand at the moment. Monty and the boys, they have no clue. They
right, right,
what's going on, why it's doing this.
right. But it's not over
Monty can
unity.
be heard in the video saying, turn it down, and they're at 7%. They're at 6.5 watts already still, and
Right. I applaud them. I think I hope,
melt.
but I hope they're right. I disagree. I'm saying that the term over unity, that's not what's happening. You can tell me that's your opinion, but the over
Well, yeah, it's
unity
taking
has
energy
the
from
I
somewhere else,
the
for
whole
sure.
right. Then it's not over unity. It means what it is. Over unity is thrown out, and what we should say is it is producing what seems to be more energy than we're putting in, but obviously it's getting it from somewhere. We don't know where
We'll
that
we'll have to
is.
talk about it in percentages like they did on the video.
Yeah, that's the way you do it. But I'm just saying that the over unity concept has to be thrown out.
it'll be more efficient. It'll be more efficient than wind power, and
No, I
that's
saw, I
going to
saw
be
it. I saw it.
awesome. That's going to be
Oh,
awesome if they can get to $20 million. Oh, all
oh,
bets are off.
absolutely. I am here. I will applaud them, and I will. I am again. I'm not against it. What I am against is our use of language loosely, and it gets us into trouble. Let me tell you this: the Sapphire Project is an amazing project, and I think it's great. I give them
They're
a
breaking
hundred
the
percent
rules of
applaud.
physics.
But no, they're not. The rules of physics, there are no rules of physics. The universe works as it works. We just don't know what's going on. We have to stop
Exactly.
using that. Again, the phrase that it breaks, there's anomalies. There's no anomalies in the universe. We have bad theories and models and
Just don't
mathematics.
understand what's going on
Exactly,
at certain
exactly.
in certain areas. That's all.
See, exactly. We just have to be careful because the moment we use over unity, the rest of the world's going
Oh,
to
sorry. I should
believe,
say
throw it
they're
out.
breaking the rules of the standard model of physics.
Yeah,
Ooh.
that's easy to do. They break
Not,
their own rules and they don't even admit it. So
maybe not your rules of physics, but I'm just saying, like
no,
when
they do it all the time. Well,
when Monty came onto the Electric View and he was talking with us, he told us specifically that they hired a physicist to come in and look at the data, and the physicist could not make sense of what was going on, and he got all flustered and he quit. Basically, the Sapphire broke the brain of the physicist that was hired to look at the data. He couldn't understand what was going on because it's a model that is not based on an atomic model of the sun. It's an electric model of the sun. I don't hear you, David.
you know what happened?
There you go.
My head hit the mute button,
Hey,
and actually, four people in the comments applauded. Sorry, I'm back.
well, I'm
But
a gamer since 1993, 94, so I understand communications on voice over
right.
internet.
Oh, that's for sure. But anyways, I do want to I want to thank you. What time is it here? It's 11:11. We're coming up 2 hours. First of all, I want to congratulate on your total attitude of coming in. I think the Electric Universe has a lot to offer. I think the Sapphire Project is absolutely great. I'm here as a physics police and the language police to try to get us to use the right terms so that we are, what we don't. One of the things I don't want us to become is fanatical. The moment we become fanatical about any idea, we're screwed. Because
No, I fully agree.
fanaticism about the electric universe or fanaticism about my our model or anybody else's model is what drives us in the wrong direction, and it also drives people away.
Right. Well, from my
What I
view,
want to make sure is let's stop. When I hear a person like yourself, I've been around these people for almost 30 years. We've come to learn some things in like energy as a concept. It is. People, we've said that so much that I've now seen several mainstream scientists admit, yep, energy is a concept because no one's put their shoulders against a wall. We need to start realizing that we come up with ideas, we have to understand what is the difference between a model and a what we
a theory.
describe.
Yeah.
No, what we describe is what is happening versus what it is. And what we have in the electric
Right.
universe is really what is happening, and that's more
Theory.
electrical. And I plot, yes, what it is what other people like myself and my father, we're trying to give a person with a book. Everything's gravitic, electric, luminic, or magnetic, and this is why. And here's our model to show that. Here's what we have come up with. How do you say models that can show this? It's predictions of what these things are. We're not saying necessarily we have to obviously describe everything there. That's different from saying the world is more electric and here are the things that are going on. But the problem is the moment we get more, fanatical about it, we then start to say, no, I'll give you an example of fanaticism. I gave our book, an earlier version, to a friend of mine, and we said gravity is a push from a particle because we have a force that's pushing us down. It's a push. There's no such thing as sucking in the universe. You can only get something to move by a collision. That's it. So when I gave it, we put the book down. He put it. He read the first, tried to get through the first chapter. Put it in my desk. He says, "I can't get through the idea that gravity is a push." I says, "What do you think it is?" "Oh, it's space time." I said, "Well, space time is a tensor equation. I know I have a degree in mathematics, so I know the math behind it. It's just mathematics. It's not a physical anything. It's mathematics to hopefully describe the
Hmm.
movement of bodies through that mathematical field. It ain't real." You know what he said to me? Tensor equations are physical. So the problem is that when we start to be fanatical about an idea, we start to say it's a model. We start to say that the standard model, which isn't a model at all, and here is the best proof. If there's anybody listening to me today who's new, go to Wikipedia and look up quark. Quarks are supposedly physical things that make up protons and neutrons. Go look at the model they have. There is no model. It's a it's a circle, a perfect circle with three perfect circles. This is from Wikipedia. I can look it up now and show you. The standard model is anything but a model. A model in English in most languages mean a physical thing.
Well, don't forget about the Bose-Higgs.
The what? Bose-Higgs. Oh yeah. Well, read the Higgs fake by, if you want to learn all about that, read the Higgs fake by Dr. Alexander Unsker. It's a wonderful book. The Higgs was invented. It's based on a house of cards like anything. But what I'm saying to
Yeah.
everybody is, be careful to say the electric universe is a model. It is a
No,
wonderful.
it's a
It
set of theories.
it's a
I
set, it's a great set of ideas that say, hey folks, we're not going to tell you what a magnetic field is or what charge is, but we're telling you the universe is way more electrical than we think. And I applaud that. Sapphire says that the sun, we think, has a different model. They don't tell us all of how the atom works and all those, and then they're not going to. But I applaud them, and I will be the first to tell you I don't know enough about the
they're
standard
saying
model of what the sun
they're
is.
saying nuclear reactions can happen in low energy,
Absolutely, and I absolutely
and
could
that's what's
could
happening.
agree
They're
with that.
showing it.
But it isn't. It's a new model of the sun using the current standard model of atoms, and that's fine.
Well, it's using an electrical model based on an anode and cathode relationship.
Yes, that's fine, but I wouldn't, again, I don't know if I'd call it a model. It's using the same physics of the standard model, which isn't a model either. What it is saying, it's saying the standard rules of the way we say the universe works. We're not saying what it is. Those standard rules we can use in a different way and say, it's not this, it's this that's happening. So again, to say it's a model, I the model of the sun, yes, that you can say because it's using atoms and the atomic structures and all that. To say that that's using more part of the electrical part of the standard model,
Well, they're
fine.
creating the same tufts that we see on the surface of the sun. They're
Absolutely.
they're they're creating the double layering that we see in the sun's environment. They're also seeing high temperatures because of the fact that these electrons have to ramp up to go out out past into the cathode area. Uh,
Yeah,
that's
that part of it, again, the only thing I would
that's
say about all that is that, again, we're talking about
that's
forces
the model of the
that
three
we don't.
modes of electricity: arc mode, dark, glow mode, and dark mode. And your father
Right.
knows that very well, right? He's an
Yeah.
electrical engineer. He should know those
Yeah,
modes.
but the explanation for it would be different. But here's what I would say to you, Rick, is that I will, if I were to bet right now, and I would say I would bet money on the electric universe's model of the sun. Uh, their model for gravity, their model for, they don't have any explanation for the charge in that. That's fine. And their sapphire project of recreating the sun and saying these things happen and then proving that by saying, here it is, I applaud them deeply.
Well, they're
But
also using things like when the interaction of the copper plug on Comet P67, which I was watching a video of you, and you couldn't remember P67. That was the
right.
comet that they slammed the copper plug into.
Oh yeah, 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 yeah.
Saw the
Sorry about that.
flash
Yeah. Oh yeah.
before, and then they saw the impact. That flash was the difference in potential between those two objects, the electrical potential between the two. You see, the copper plug came from Earth. It
No,
had a
no, I understand that,
potential than
and
the
I think
comet.
that what yeah, and I think that's super, and I think it's absolutely great that the electric universe are making predictions and try to give explanations, and that's great. You know,
I'd
my
like to
father and I,
address
my
John's
father,
comment there. No, the standard model is not completely electric. The the cosmology today is in a quandary. There, if you go and ask a cosmologist how these magnetic fields exist in the universe, they will call them static magnetic fields.
yeah, but I'm going to
They
tell you,
say
Rick, I'm going to
they
stop you
don't.
right there because the electric universe does not have a model for magnetism either, and
Yeah,
so
we say the
so
movement of
you
charge
know
creates the magnetic fields, and then it then
charge doesn't
and
tell
they
you either
pinch
because
down
charge is an
to create
attribute.
galaxies, and they
I
break up
can
in
make
smaller.
I can make any particle and call it a Daviton. I can put a arbitrary thing like a charge or even something else I make up and explain the same thing. So you're still not saying what the magnetic field is. It's not what you guys talk about are the same things the standard model talks about, which is charge movements and do they create fields. And the reason you can't say that or say that it's better than the standard model is because we do not know what charge is, and until you do, you can't say that the electric universe is any big. Here's what I'm saying: the electric
Movement
universe
of electrons is charged,
uses
right?
the standard model's electrical idea in a very different way.
Well, I
The
understand.
dipoles, all the things that I find in the electric universe explanations are in standard model. They are rearranged and they're explaining different phenomenon, but they are not saying anything. They're using the standard model in a different way. That's what I'm saying. So when you say no, no, they do this and we do that, they're still using the standard model, the model. It's just in a different way.
Well, they're just using electricity in a different way. They're looking at
Yeah.
electricity as
But electricity, what I'm
being
again,
the main force in the universe instead of it
it
being
is.
non-existent.
It's only you say that with your words, but I would say what is electricity and what electric. Again, I'll go back to what is all those things. So again, it's a what you need. What I would say to this is the standard model. What this person is saying, in some
We,
sense,
we
is what
use
a lot of people in electric universe think, and that is the main force in the universe of electric. But again, I'm still saying, well, it's really interesting. Is it? Is it not? What's your model so we can actually verify that? The problem is we don't know what those are. So when we say it is, everybody, including the general public, is going to go, what's electric field? Because if you say it's all electric and you're not telling me what that is,
Well, we know on Earth we power our computers with electricity, moving
but we don't
electrons.
know. But we don't know what that is.
I call them angry pixies.
Yeah, that's better than the standard model. The
But
standard model calls them electrons, and they say because there's a positive and negative something, and that things move, and magical charge causes that to happen.
right, and
Here's our
these
standard here's our standard model for you. You start on a battery with electrons going around. They have a chemical reaction, which is zinc and copper and zinc oxide and all that stuff. Then we get electrons flowing
moving from one plate to the other.
one atom to another. The current we measure are holes, which are nothing moving in the opposite direction. These electrons get to an antenna. They magically turn from electrons into photons, and that's one of the reasons some people propose an electron's made out of photons, because they can't answer that question. And then they go out into the universe. There's all kinds of things that are happening in electric circuits that just don't have explanation for.
Well,
But
are you talking about the glow around a high power antenna, radio
no,
antenna?
I'm not. No, I'm just talking about the electromagnetic waves. What is light?
Oh, I misunderstood you there. Sorry.
Yeah, yeah. No, no problem. I'm just saying that even electric circuits, we have electrons turning into light, and no one talks about it.
Well, I see. You see, this what leads me to believe that those two scientists in the 30s were correct in their assumption that an electron are just basically two photons.
Well, here's the problem with
Electron,
that.
you
Yeah,
add
but
enough
here's the
energy
problem with
to
that.
that electron, and it will split into a photon or
Okay,
two. Sorry.
let me tell you why. No, no problem. Let me tell you why that doesn't work for me. Because a photon doesn't work. A photon, even Newton didn't accept the photon because he came up with the idea of ultra mundane corpuscles. And basically, what he was with one of his contemporaries, he was saying, okay, well, a photon, a particle that would have to carry light, would have big ones and small ones because they'd have to carry frequency, blue light and red light. So how is a photon, one photon, which is by concept in the standard model, a one kind of particle that can bring all these different frequencies? It has no explanation for that. So no matter, even if you think that an electron turns in, is two photons, you then inherit all the problems with the photon, which doesn't work.
If that was the case, we would have more than just rods and cones in the back of our eye.
No,
We
but
would
we have
have
a
we would
our
have
when the book
multiple
comes out, I'll send you our book. We
intelligences there
talk
were,
about that. We talk about that.
right?
Because the rods and cones are really detecting differences in frequencies. There's even
Yeah,
a dispute
the
whether or
wave.
not, if you look at it, my father and I have looked into the biology of the eye because for our model we looked at that. It's still not absolutely certain about the red and blue and green even. That it may be that there are two types, and the other ones simply detect different frequencies and send those to the brain, which then interprets it into the colors. So I mean,
Right.
it's really hard. But
Yeah,
what
there's
I'm
a lot
saying
going
is,
on there for sure.
what I'm saying is to you, be careful. All of these things, when people say, "Well, I think it's the photon and it's two photons for an electron," well, you're inheriting the problems of the electron, which there are many, because you have here's what you ask an electrical engineer who's used electricity that travels almost at the speed of light at times, and they measure it in the lab. They measure an electron moving at meters per second.
Does
And
your
yet they
system
talk
have
about,
a table of elements?
no, we don't go, that would be what we would call universe hack 4. My father and I have not gotten into the periodic table.
Have you looked at SAM?
Sam? I'm not sure what that is.
It's S period A period M period, the subatomic model. Or
Subatomic
hang on,
model.
let me bring it up again. It's the electric
Yeah,
universe model of a new model of the atomic structure. Oh, sorry, it's called the structured atomic model.
right. No, I haven't seen that. Yeah,
You should look into it. It's interesting.
no, I believe it. Actually, I know of now probably about 6 models for the atomic structure, and
Hmm.
they're all interesting. You can find things and things that people each model have come up and have been very good. I
Well,
will
they're saying that electrons.
our model does not do that. The only thing our model says is that most likely there is not one particle for the electron, that it's actually a quanta of particles, and there's no such thing as a neutron because we don't believe in charge. It's just a nucleon. But beyond that, we do not go beyond that. We don't claim to know beyond that. So
Well, the structured atomic model, they're talking about electrons binding the protons and neutrons together,
yeah, but
and
they also again
also also other electrons orbiting.
I
So it's
know,
interesting.
but they are using charge still, right?
Yeah, definitely.
Yeah, and that's them. We don't need that. So if you look at simple models, ours is simpler. Now, is it right? No, no. Is their model right? I don't know. So I'm just saying. The only reason I don't look too much is that if it's based on charge, I don't believe charge exists. So I have to. What I normally will do is look at maybe the physical setups they're proposing. I know Jeff Yee is proposing a sort of tetrahedral formation of nucleons, that they're just spheres. Other people have rings. Other people have.
Have you heard of a fellow named Buddy Guy?
No.
Um, he is sorry, not Buddy Guy. Buddy Doggerty.
Hmm.
He is doing the same kind of things as Fractal Woman,
Okay. I'm
and
not sure
he's
what you mean by the same kind of things.
um, basically using the Mandelbrot set and fractals to try and explain what's going on.
Oh,
You
I
might be
see.
interested in it in his channel on
Oh,
YouTube.
it could be. I do use a Mandelbrot. I asked one from Lori Gardi because my contention is, and I got that with talking about it with her in a car when I was in Vancouver during the conference, was that actually fractals are very much like the infinite universe, both up and down infinitely, and that in a certain area of the universe we see things like, you see me and my image and all that thing, but of course down further they're smaller and smaller. A lot of the galaxies that come out that look sort of like fractals is because they're actually processes that are repeated, just repeating themselves, because chemically they go through these things repeating and they'll cause patterns that look like fractals. So I believe fractals gives us an insight into the infinity part of the universe, and I have an explanation in my book about that. So, but as to actually a model for it, I think it's more, to me, it's more that these kinds of the way it's set up, that is, uh, when you look at something that's a circle, it's not really a circle because you get close to an atom, which is supposedly solid. It's not. It's mostly space, and you get then the nucleus, and then that's made of particles itself, and it's mostly space, and you keep going down. I think fractals give us an idea of how those things could be set up in the universe, but I'm not specifically as to setting up that they actually tell how the function of the universe. I'm not sure that's viable, but it could be. Yeah.
Well, I put Buddy's link in the chat on the Facebook or the uh, not Facebook on
Okay.
the YouTube for you.
YouTube. Okay.
If
Okay.
you,
That
if
sounds
you,
good.
if you have a look, copy and paste it, and go to his site
Sure. Sure.
and have a look
Sure.
at some of the stuff. It's similar to Lori's stuff,
Right. Right. Right.
and you might be interested in seeing some of the mechanisms that he's using. Who
Oh
knows?
no, absolutely. I am the first person. Whenever I find a person who has a new idea, a new model, I read through Lori Gardi's paper on the electrogen. She proposed an electrogen for the propagation of ether in a wire. So because the problem with ether is going to spread out away from the wire, so she
Right.
does that. I read it, in 15 minutes. I read these things voraciously. So when I see a new person, the reason is because in that person's work could be something that I find to be
Key
very good.
connection,
A
and that's what
connection.
I'm all about. That's what drew me into the electric universe. When I saw the movie called Symbols of an Alien Sky, which is about an hour and 20 minutes long, I understood all of the ancient texts that I've been reading, and that I'd understood. The ancients, Zep Tepi, telling us that the sun stood motionless in the sky. Our ancient sun stood motionless, and they didn't say it spun there, but guess what? The Sumerians, they said that. They
No, I
said
know
it
the story.
spun.
I've read
Not
and
only the
seen them.
Sumerians, the South Americans, they say the sun stood motionless in the sky.
I
Well,
mean,
you know, rises east and
that is
west.
a speculation that could be very well true, but we don't have proof of it. But those kinds of
Comparative
connections can be
mythology.
made, comparative, yes, and I totally applaud and support all that work. Whether or not that's true, that's a different story. The only thing I have is if you can come up with physicalities for why those things happen, and I'm sure you could explain that, or people can. But at least for now, I think if people are interested in
Physicalities
that, it's
in what respect?
well, one of the arguments against Velikovsky, for instance, for Venus coming in, is that we would have a lot more perturbations in the orbit even after 30,000 years. It takes many years for things the orbits that we have now in the solar system, for something to come flying in and have it so stable in such a short amount of time. That is a valid argument
Well,
for
if it
reason why Venus couldn't have flown
if
in.
it
So
followed, if
it's
it
an
was pulled
argument.
if it was pulled in from the southern pole, like Wall says, and it spiraled in along the Birkeland current, and then pinched in on the Z pinch, which is the sun, it would end up close into the sun. And
No, I mean, I think it's an explanation, but I think the astronomical chances for that coming in and looking to be totally normal now, I think that's a tough one to that's a
but we see Herbert
tough one to
Haro
explain.
objects out in space that NASA say that last about 70,000, 80,000 years. And
Sure.
these Herbert Haro objects, we're thinking that they're they're just beginnings of solar systems. They pull together over thousands of light years. This electrical force
No, I
pulls
understand. Yeah.
into
I
solar systems.
understand. I understand, and I think we can get in the explanations of electric universe a lot, and that's great. I think that's a great place for people to go, and they can look at it. At least on this channel, I have no problem of discussing certain aspects of it. But I mean, you're talking to a person where I'll listen to this and I will, you know, have my physics police hat on. So as much as that it's appealing to a lot of people, it is. Again, I think we just have to be careful and understand that when people come with counter arguments, they really need to be looked at, and you have to sort of weigh it. And if you go to an average person and you give them pretty how do you say improbable happenings and expect them to say that that's probably what happened, you have to understand the other side of the argument, and that's all I'm saying. So
Once
and
were
I
beeping at me. They're on low power. I use wireless headphones. I had to plug them in.
Oh, no, no problem. I'm going to get some other people's comments here too. But listen, Rick, it was really great talking with you. I'm going to take a few more comments. I'm going to bring you down.
Yeah, I'm gonna
Congratulations
watch
on your
some of
work.
your videos and see what you're all
No,
about with your theories.
absolutely.
And see
And
if I can.
keep going on
Again,
your journey.
I'm all about connections and trying to make the connections that, like, for instance, the birth of Venus. We understand it through the electric universe eyes that when it was it was basically a comet after it was born. It's still incandescent today, and it still has a huge long tail that touches Earth every once in a while when we get close. Um,
But
the,
there's other explanations for that too, right? And I'm not
well,
sure
yeah, but
necessarily that, in my
when I
opinion,
but
that
when I
they're
look
different, that
at
they're
the
any
North
better.
American Indian's headdress, my point is when I look at the North American Indian's headdress, I see them commemorating the birth of Venus and all of these cometary tails streaming around Saturn. I see
Yeah,
that
but I
physically.
know, but it may be
I made that
there.
connection
Look,
myself.
right, but there are literally patterns that are made both by electric currents and by other processes that when you look from far that look fractal, that could be made in several ways, and what could be made one
Scalable.
way. Right, but what I'm saying is there can be several answers to that, and that's the only argument. And you
Understand?
can, and that's what I ask people, and I know there's a lot of people in electric universe who do think that way. I
Well,
just,
see, I
again,
my idea on
when
the
you
electric
talk about it, you can
theories
feel
are
like it's like you can feel almost like a belief system there, and that
well.
belief system
See,
is
my theory on that is I I believe not 100% in the electric universe theory. I believe that there are so far the best that I've come across. And I've looked at a lot, like hydrogen, metallic hydrogen, sun. I've looked at all kinds of different theories. I've looked at all kinds of different YouTube channels presenting different theories, and none of them stack up to the electric universe. I'll look at yours
Well,
and
no, that's no problem. Ours is very different. Our
well, I
goal is to
understand
give it
yours.
physicality. It's not to
I
everything
understand.
in the we will agree with the electric universe. The difference between ours is it's a model. It's not a theory. That's the difference.
Right, I understand. I understand.
So it's not like it's not you're weighing sort of like a person who describe a
and the
computer
more eyes
program.
looking at your model may be able to find some connection
Could
to
be, sure.
maybe what's going on in Sapphire with
Oh
the
no,
dark
no.
energy.
I already see a lot of connections. In fact, the whole thing about what's electric in the universe and what isn't, our one page of what I call movement classification will give you that answer. And so, but of course, you have to have a model and believe a model of that a magnetic field is simply a loop of particles going around and round and round. If you don't, if you don't subscribe to these characterizations, then of course, it's the model's going to be useless in that sense, and that's okay. It's not. But let me
Go
sort of
ahead.
cut because I want to let things go. I'm gonna thank
Take
you
some
again.
comments from the
Yeah,
crew
and take some
that are watching
comments.
you.
And
Yeah, yeah.
congratulations. Keep going. I do want to address some of the other comments, but thank you very much for coming on, being super
It's
polite.
sad that nobody
Uh,
else
uh,
is in this waiting room. I mean, come
no,
on,
that's okay.
folks.
That's okay. That's okay.
I'm
Sometimes people
joking.
get intimidating, but take care, and I'm going to bring you back down. All right. I'll leave
Well,
you
to
in the
tell you
waiting
the truth,
room.
I was intimidated. That's why I left. But then you wanted to hear an explanation, so I figured, you know what, I'd
Awesome.
come on and talk about it.
Absolutely. And there was a lot. I always learn things from talking with people too, as well. So thank you so much, Rick. Okay. Take care. Alrighty, I'm going to answer some questions. Debate in mendum. I have done that. It's sort of futile because it becomes a name calling game, and I have can't remember his name, but he has another channel. But anyways, a couple of years ago, I went on his channel and did talk with him, but even his own followers got so upset with him because I was being very calm about it, and he could not understand my point of view that the charge was not real in the universe, and he got more and more and more emotionally totally mad that all he could do is swear. There was no interest for me because it wasn't even a discussion like I just had with Rick and Shockwave, which was wonderful. He talks about the electric universe and how that really connects with him. And I tell people, if it connects with you, great, do it, go all out at it. But I will not back down when a person uses words or things that I believe aren't going well. So that was, something I tried. It's just not worth my time. I don't think it's even worth anybody's time. The guy's more made up. If he has his ideas, if you don't agree with him, he doesn't have that ability to debate. That is, if he says something and I counteract with my explanation, he doesn't then come back and say, "Oh, okay, I can see what. Maybe I'm wrong." That's just not a possibility with him. So I found it to be very unproductive and not really interesting of my time. I'd rather go in with my daughter and do something with my 14-year-old daughter and have fun with in life and play a game with her or talk about theater or than waste my time with somebody who's truly not who says they debate and talk and are open-minded, but I don't see evidence of that with that guy. So I've really stayed away from him. So let's see here. Dave, glad to see Friday Night's Physics back on the tube. Yeah, that's cool. Duplicate, I do remember. Again, invite people to join in this. Like I said, I don't expect tons of people for these, but I do know that a lot of the subscribers, I've got over 3,000 of them now, do enjoy these kind of sessions to ask direct questions and get my direct answers to them or discussion about them. And of course, you can Shockwave, come on, Rick, and talk directly with me. Let me see if there's anything else here about Shockwave. Okay, I'll take a look at that link that Shockwave gave. Um, let's see, I don't know what he says. I'm sorry, Shockwave, I didn't think it came through. Oh, I'm not sure. Oh, the link. Yeah, you can send links through here. It will be recorded. We've been going on for 2 hours and 13 minutes. Let's see, anything else here? Um, okay, here's a good one that I'd like to say about. This is John Custord. How do you explain inelastic scattering if there's no quarks? Well, this is pretty easily explained about. Um, it really comes down to the fact that particle physics has become totally not physical at all. It started with quarks in the first place. They don't say quarks are circular, spherical. They don't say what shape they are. They don't give you any physicality to any of that. So what they become are arbitrary packages with arbitrary attributes. I'm not the one who says that. That's said by a doctor of physics from Germany. His name is Alexander Unsker. Again, I encourage you read any of his books. He has even a channel. Just look up. I think it's called. Darn it, I can't remember what it's called. Um, Bad with names. Anyways, so the whole thing about inelastic scattering, well, first of all, quarks are invented, they're not real. So the whole idea here is that, in fact, if quarks aren't real, then who cares? Because if you don't believe the science that supposedly discovered them, which I do not believe that the scientific method was properly followed in most of the time. 99% of the time in particle physics, it is not properly followed. Then I don't subscribe to the invention of quarks and then pretending to find them. So whether or not there's an elastic scattering is talking about things that don't exist, in my opinion, and actually many people's opinion. There are literally thousands and thousands of scientists and critical thinkers around the world. What is the problem with it? I'm saying with what? I guess. Oh, maybe he's talking about something else. Um, Perfectly. How do you? But the data fit perfectly. Of course it fits. They have a system. Look, when they come up with a system, their system has a numbering system. But the problem with their system is that when you get to how they got to those numbers, they make leaps and logical leaps that are simply wrong. They are wrong. Now, again, until you read the physics, the how they come up with what they come up with, and how they do the actual science, the scientific method of the engineers who collect the data, the computer programs they use to filter the data, and all of those things, until you look at those things the same way Alexander Unsecker has, you're not going to convince me that any of their numbers, no matter what their numbers they come up with, are agreeable. That are, how do you say, the mathematics behind it. So the problem is the way they filter things. Again, read the Higgs fake. When you read the Higgs fake and come back, then talk to me. Also, read Lost in Math by Sabine Hossenfelder, who worked on the Large Hadron Collider, left the team and wrote the book Lost in Math. Why do you think she wrote that? Because they're lost in math. They are so interested. The answer to John is Sabine Hossenfelder, who has now her own channel. She says in her book, Lost in Math, I wish you would read it because it's easy to talk about this stuff because you're talking about what they throw out into the press, not about what goes on behind the scenes. She says that the symmetry and all those things are mathematical. It doesn't mean the universe is anything like that. So, unfortunately, that's the way it is. Yes, she is. Sabine is a very smart individual, but she is also, I have some opinions. She had a chance to become a critical thinker for real, but she is now turned into a science evangelist who's now making a channel about just talking about things that are safe. She will not say Einstein is wrong. She will, even though we have massive data for that, including particle accelerators, which violate special relativity every time they use it. That is in my film and documentary, Einstein Wrong. So Sabine is a smart person, but she, in my opinion, is going now for popularity and growing her channel and making a living off of that. And you will not make a living, like I do not make a living, criticizing mainstream science really when it is wrong and people know it's wrong. They don't have the guts to say it. So Sabina, I'm sad to say, I'm sad to tell everybody my opinion is that she's somewhat sold out. So, hey, Frank, Farouk, how are you? It's great to see you. Um, but anyway, John, that's my opinion. Mainstream science, when you look at the system they give you, which is their version of what they've done in the systems and the words they use, if you actually go in and look at the math and their scientific methods of collecting data and all the people involved in a particle accelerator like the Large Hadron Collider, as pointed out by Dr. Alexander Unziker, in fact, is a parade of, if you were to take what they do in the the Large Hadron Collider, and take a bunch of SpaceX or NASA scientists who do real physics, and have them sit in those teams, they would be horrified within an hour and leave the team saying that this is a bunch of garbage. Why? Because their scientific method is baloney. It's just not good. Yes, I understand, John. Yeah, I know what you're talking about. You're talking about particle physics, but particle physics, the methodologies used are horrific. And they do it, and the people, and I will tell you another thing, and I have not made a video on it, but Alexander Unziker is brave enough to say that. And that is, it's not the best minds that go into theoretical particle physics and theoretical cosmology. You know why? Simple, because it's so based on such malarkey, such baloney, that the people who are lucid and want to look for truth quickly realize this is a fantasy land of a bunch of people who are psychologically fanatics about something, who are willing to sell out truth for a position, and they go running screaming away from theoretical physics. And we don't get the best minds in physics, in theoretical physics. We get the people who are willing to sell out. That is, oh, I will explain quantum mechanics to you and say it's so wonderful and so beautiful, and symmetry is so beautiful, and how the Higgs boson is so beautiful. Yet we all, in deep down inside, we don't know it, but we all know it's a bunch of malarkey, but we don't care because I'm going to get my position in. How do I know that? Because in my film, 50% of the students in the advanced physics in high school said they would forego truth over getting their position. They would throw away truth to get their position at a prestigious position at a university. They'll forego truth. So there you go. It's a corrupt system. That's it. What do you think of electrons? Do you know Stoyan Sarge? Yes, I know. I've got his book right back here. He's a friend of mine. I do not believe in the electron in the sense that it's a charged particle. I do not believe that electron is the particle we think it is. I think, in fact, the electrons, all we do know are there are beams of particles. The measurements for the electron are really not good measurements because they use it in a gravitational field. That doesn't work. So it's the electron. We replace it with a different particle. That's a neutral particle. All particles are neutral. There's no such thing as charge. And we think that there is a nucleus, but we think that the hydrogen atom does not have one electron, but it has many particles that go around the neutron, or what people call the neutron, or what we call the nucleon. But we don't go further than that. But our model and our feeling is that, and that's why we there is no evidence for the electron and its real charge. Those things are done in different ways. They're still done in masses. We never have isolated one electron and measured it because we can't do it. Electrons are, you can't measure them on a gravitational scale. We say then we measure it with electric field. What we don't know what electric field is. So the whole concept of the electron, no, we don't have it. We have a one particle that replaces. Again, this is our model. It could be completely wrong, but our one particle replaces a graviton, a photon, an electron, and we also say it's also does the magnetic field, which there is no particle for a magnetic field right now, although some people say it's an electron. That's that's what I think, but that's my personal opinion. Jeff Yee. I know. Can you believe that, Jeff Yee? This is the greatest hat, isn't it? Actually, I have this whole concept for the physics police um, as a cartoon, like the um, based on South Park. If I can, I actually was thinking about pitching it and then doing all this criticism of mainstream science, so that great models like you, Jeff Yee, is in the house. I want to say hello. Hats off to Jeff Yee. I love your model. My father and I have our own model. I love all of everybody's models. Even if I don't agree with them, I still love them because I love the idea of people coming out with them. And I think Jeff Yee is one of the up and coming stars, and I really like his model a lot. Um, and I don't know, did you know that Yonel Danu and Lori Gardi are now working on an ether type of model? But then again, if you haven't checked out Jeff Yee's model, look up Jeff Yee energy. In fact, I'll put that up there. I think it's energy. Just look up wave energy. Is that what it is? Energy wave theory. I think that's what it's called. Yeah, energywavetheory.com. Go to that and take a look at it. It's definitely worth your while. I highly recommend you go to it. Energywavetheory.com. I'll put that up here. There you go. Did I spell that right? So Jeff Yee, great, great model. He's got some. We have some videos of him on our Saturday morning chats. But if you check it out, my gosh, that guy has. You talk about really thoroughly going detailed in a model and explaining things in a much simpler way. He does that, and I'm one of his biggest fans. Like even though I said we have different models, so let's see. David, put in the link for John to join. Oh, I already did. I only have a few more minutes. Yes, if you go to this link, greenroom.dissidentscience.com. I could put waiting room. I like green room because, but you can, if you go to that, you can enter into this and I can talk to you face to face. But we are going on 2.5 hours. So what time is it? 11. It's almost midnight here. If you're on the West Coast, it's cool. If you're in Cork, Ireland, like my boss is, it's now almost 5 in the morning. I think it's early morning in Australia as well, but in Europe, forget it. This time frame doesn't work for Europe. So unfortunately, I have people in Europe who do want to join in sometime. But yeah, that's how you get there. And but John, I invite you to join me next time if you can't get in this time and to talk. Again, if as long as we have a civil discourse and we listen to each other. One thing I don't enjoy is talking with people who are one way. The only time I really have no problem with that is if a person is giving a talk or if I invite a person to talk about their theory or whatever. And usually I do that in an interview style, and then you have go for it, talk about it all you want. But I'm only interested here to sort of have dialogue and go mano to mano, person to person with thoughts. And that's what it's about. So I don't need any saviors or people who come on and want to tell me the way everything is. But if you want to discuss things or have questions and want to have a discussion about it, like, oh, your opinion about it, my opinion, and you talk about your opinion, that kind of thing, that is absolutely great. So yeah, yeah, that's what layers are for. I thought you said lawyers. So, do you think force fields are possible? I don't know if that's for me. Um, Fields exist, what we call fields, but they are physical. They all have to be physical in the end, in my opinion. I'm one of those people that do not believe in magical fields doing magical things. So, our model has a gravitic field and it has a magnetic field and it has a, actually, those are the only two we have, light and gravity. But those are fields because they're particles that act in manners that are, so, and the groups of particles that keep in a sort of a formation. One's random and one goes in circles. That's about it. But so yes, force fields are exist. Those are handy dandy things to talk about. But to give an example, gravitational field, my father's done calculations that it wasn't a field. It was literally lots and lots and lots and lots and lots and lots of small little bumps by little particles. And believe it or not, he came up with the same curve as Newton did using the force of small little particles. So I believe that fields are really um, something. So, yeah. Um, what else? Anything else here that I see before I go? Dave threw a tantrum and blocked me because I pointed out the flaws. No, you didn't. First of all, you didn't point out the flaws. You just said things like idiot. So you have no debating skills and you waste people's time. I mean, if I had a debating coach, you would absolutely, you haven't proved anything. You just say idiotic. You haven't proved a thing. So, um, uh, trolls, it's funny because that's the exact same reaction you get from people in the mainstream, like Neil deGrasse Tyson. His answer to Einstein being wrong is laughing. That's not in any way a critical thinking or scientific attitude. It never will be. So, that's like a baby. This is like a little kid talking, and maybe he is a little kid. So, but it's interesting. It's just, it's sad, really, because if you have a person who's spending their time doing that, they could be doing anything else. Help somebody, do something. You're showing only that you have no ability to do critical thinking or scientific thinking, and that the debate. So I put you in a timeout like a child, and guess what happened? You came back like a child. I mean, it's pretty funny. So, anyways, um, oh, here you go. You never answered John's question of a tensor. Still Googling it. I have a math degree. See, again, that's the whole thing is tensors is mathematics. It's not a physicality. So tensor equations, which are the equations that describe space time, it's nothing. It's just mathematics to describe how bodies will move around other bodies. I can come up with 7 explanations for that. So, you know, uh, nope. I pointed out that it has 0 explanations. That's absolutely not true. That makes no sense. Give you an example. We explain what electricity is. We explain what light is. We explain the wave particle duality. We can explain the double slit experiment with the detector, which no one can explain. So, I mean, that's just, these are words, right? These are words. Anyways, again, it's not worth it. Just not worth it. Okay, blocked. All right. Anything after? Okay, here's one for John. Maybe he's talking about discussion and see what you don't actually believe in the accepted model. Oh, okay. Yeah, I think that's good. And I'm absolutely willing, John, to talk to you about that. And like I said, I'm not really interested in people trying to convert me to say like the neutrino exists or something like that. But if you want to know what I accept and not accept, if you want to go to my, that would be fine. You can see symmetry with your eyes. Well, again, if you want to talk about symmetry, symmetry is there are actually quite a few people in regular physics, including Sabine Hassenfelder and including other people, that symmetry is starting to, people are realizing that is something we as humans are imposing upon the universe. Do we have to have a positron and a negatron, whatever you want to call them, a neutron and a positron and a negative charge particle and a positive charge? For every electron, there's a positron. For every neutron, there's a particle that's completely charged. No, that's something that we have human beings put upon it. So no, symmetry, we have to let the universe tell us about it. We see symmetry because our minds are made of neural networks. I'm a computer scientist. We can simulate neural networks very well. We know how they work and why they work. And guess what? Their job is to find patterns. That's why it's so good at recognizing faces. So because of our brains are made through evolution because of the way neurons look at the world through our senses. Its job is to see patterns. It doesn't mean that the universe is full of symmetry at all. So, anyways, um, yeah, where can we go to learn your model? Oh, again, you're going to have to wait for the book. That's why we're writing it. But you can learn a little bit about my model, my father and I's model, at our website. And our book will be coming out in the fall. We do think it's got some pretty amazing ideas in it. Um, the people who know it and who actually understand it, they think it's got a lot of good things to give into the world. But if you look at our class movement classification, it really tells you the whole model. We just then go and apply it to everything, and it explains quite a lot. So we're really excited about it. We do have a channel for it as well, a YouTube channel. You can hear some of the discussions. We don't talk a lot about it because we're having to write the book about it, and so it'll come out in the fall. But it's another model out there. I think the only difference is that we don't have the problem of what is it. We actually give physicality to everything. So but in the model, actually, John, it does say in the model what we do support and what we don't support. If you find that, if you click on particle model, I'll show you that here. This is the website, the particle model. Out. TPM has no need for the following modern concepts of directly disputes them. All behavior observed in the universe can be explained by our model without these concepts or theories. Relativity, both special and general, don't need them. Four forces of nature. There's only one force, the Newtonian force, so we don't need the four forces, the Big Bang. No, we don't. Our model shows, or at least points to that. Redshift is not because of movement. Dark matter and energy is not needed at all. Is invented. Expanding universe, again, it's not needed. Charge not needed. Neutron we don't have because we don't have charge or neutrality. Having charge, if you don't have charge, you can't have neutrality, so we don't have that. Electric fields, we don't believe there are. We believe there's magnetic fields and gravitic fields, but not electric ones. Parallel and multi-universes, we don't believe in those, that are some existence parallel universe or something. Everything has a space. We have small, teeny, infinitely small, much smaller universes down there, but they're physical and they're in the space. They exist. Plate tectonics, we support expansion tectonics. Time travel, time is movement. Movement only goes in one direction. So the things that we do believe in, all phenomena in the universe is mechanical, all infinite. Universe both is infinite, both in space and time. There are faster than light speed particles. There have to be, because we believe that there are no particles that going at the speed of light are curving. The only way that can happen if other particles hit them. If other particles hit them, they have to go faster than the speed of light. Those are of course implied, but in our model they have to exist. Expansion tectonics, and then we explain these phenomena with physicality. Double slit experiment, laser light, wife-pipe duality, physics behind electronic circuits and components, which we don't have any explanations for right now. White light turns into rainbows, dispersion, that's a real hard problem. So those are some of the things. And of course, what we don't have here, and that's in the book, is really the base, our model based on Newtonian, is based on Newton, Lesage, Borchert, Deneau, my father, and myself. But again, this one picture really tells our entire model right there. That's all you need, really. But we explain it and add to it. So again, that's our model. I'm not here to push the model on my channel, Dissident Science, but people do ask about it. So that's what it is. Again, this is Dissident Science. Next time you want to see us live, I'm going to be leaving everyone now because I know people join later. Been going on for 2 hours and 38 minutes. I want to thank all my subscribers. I do have another scripted video with my graphics, which are really easy on the ears because it goes through, it's scripted. So those are much more fun, and I get people listening to those all the way through. Because rambling on always isn't the best way to get across. I know Jeff Yee makes really great videos. Love his videos. I took a cue from him as well. So I do have my next video scripted out. It's about ether and the problem with people claiming that it's the only answer for light. It isn't, and I'm tired of hearing that, and I'm going to tell you all about why that is. So there you go. I am the dissident scientist because I also get after the case, on the case, and that is go after dissidents as well. Just because you don't believe a lot of things in regular mainstream, I do support you, but I will not support bad behavior, bad words like, oh, this is proof for ether. There's no proof for any model. There is data that can support your model, and if your model explains something better, simpler, and people like it and adopt it and then use it to do things, you win. But the idea that you can prove any model, nope. And I keep hearing that over and over from the distant community. Oh, we abandoned ether. Well, you abandoned it if it's right, but it's not the only model out there. So, anyways, thank you so much. Again, I'm David D. Hilster. I'm going to be here on Fridays. I think once people know I'm here, it sounds like it's working out. Do look for my videos. Check out my father's YouTube channel. If you are interested in the particle model, you can go and check that out at youtube.particle.guru. If you want to check out Yee's work, go to energywave.com. If you want to check out Fractal Woman, look up Fractal Woman, and you'll see another really critical thinker and fun mind, an amazing mind, Lori Gardee. They're all out there. So thank you so much, everybody. And everybody have a great weekend. We have in Florida a hurricane coming our way, but it's a small one. Don't worry, we'll be totally fine. And hopefully I'll get my video out in the next week. And subscribe, let other people know about the channel, and keep yourself. Don't say things are proven. Don't say, don't criticize other people who are trying to go against the mainstream, because we all need to help each other. We all need to allow everybody to come up with everything. I may disagree and think you are completely wrong, but I give you 100% the right to do it, and I applaud you and will support you in your efforts, even if I don't agree with you, because that's the way science should be. And who is the judge of it? The public. So will they pick Jeff Yee's model? Will they pick Ginsburg's model? Will they pick Yonel Deneau and Gardee's model? Will they pick our model? That's up to history and everybody. But in the meantime, Jeff Yee is going to work like crazy on his model, make it better and better, explain more and more. We'll do the same with our model, and let's all support each other, okay? All right. Take care, everyone. Ciao for now.